Zoom. There you go. Okay. Sorry for that. So when you think about computer software, for a moment, I'm going to go ahead and all right. So think about a vertical box. Right. So think of a phone as a computer, right? So when you look at it at the bottom, whatever you touch it and feel it in the hand is nothing but a hardware, right? So you're going to see it in hardware at the bottom layer. Okay. Now, depending on whether you have an Apple phone or any of the Android phone, right? So Apple phone will have an iOS as in what is known as the system software. A lot of times it's also known as an operating system. Okay. And the Android phone has an Android as the system software. Okay. Now, this system software is essentially communicates with the hardware to something known as a firmware. So when you're trying to make a phone call, right, system software will initiate the communication, says, hey, convert each of this number into signals and send it to the radio tower, which in turn will get that response back as a signals. The hardware will take that signal and it will convert into specific bytes that in turn through the firmware gets back into the system software. And on top of that, what you're going to see is something known as an application software. Okay. So let's take an example, right? So if you're trying to send an email through the phone, right, or even through any hardware or any of the laptops, essentially you're going to have an email software or email client, which is going to, for example, an Outlook or any of the email clients that you have it. That email client is essentially going to make it what is known as a system calls into the operating system to perform certain tasks. That essentially gets it to the system software. Now that system software in turn takes those things and then it knows it based on the hardware, what kind of instruction it needs to send it. So for example, if you look into iOS or Apple devices, the hardware is going to be different than when you look into Android, the hardware is going to be different. Whether you use a MacBook, its hardware is completely different in terms of how it communicates versus Windows platform or even to some extent any of the Linux-based platforms, right? Those are nothing but different operating systems. So this is essentially at a high level, no matter which computer you talk about, no matter what software you talk about, is going to be the hardware and software. The bottom two stack sometimes is known as the compute platform, right? So a lot of times you will hear it in the IT world when people talk about it, hey, what kind of platform it's running on? Right? Is it a Windows platform? It's a Linux platform? Is it a Mac platform? Or sometimes you will hear the word like, is it running on a mainframe? Right? So when they talk about platform, they're talking about the bottom two component of it. Okay. When they talk about the software, hey, what software you're running it? A lot of times they talk about this or potential this also at the middle layer. Okay. So when you look into at a broader category, right? Everything that you can detach it from a computer and run it potentially at anywhere else is kind of a top high-level application software. Now, there are some application software that can run only on certain platforms.
Like Apple.
Like Apple, right? And it mainly has to do with the communication at this layer, that it's designed to communicate only this sort of API, versus some software can say, hey, at the time of installation, I'll configure it to say which software it's going to talk with it. Like, so when you take in a Microsoft Office, right? You could run it in the Mac platform, as well as you can run it onto the Windows platform. So you can do that. Like, for example, Chrome browser, you can run it on the iOS, as well as you can run a Chrome browser on the Android platforms. So at the time of installation, it configures it. But this part of the software, for about 80% it's common. It's only the bottom 20% that it's going to interact with the different system software. Any questions in terms of what the basic architecture look like? Okay. So we already talked about the role of a system software and whatever the computer platform is going to be called. Okay. So typically, like, it's when you see it, the system software is kind of fairly configured along with the hardware when it comes in. Okay. Versus the application software, it's much more fungible in terms of you can install it at any point into the system. Okay. So that's what you're going to see it in the olden days. It used to come into a floppy disk or flash drives or a hard disk. And essentially nowadays, anything that you can download it over the net and install it is typically good and classified as an application software.
So those flash drives or the physical things used to interact with the platforms?
Yeah, so like it's, even if you look into it, right? Say, hey, if I want to install, let's say a text software, right? So today you can just either get a URL and download it from it and install it, or you can actually get the CD drive or flash drive where you can just go ahead and plug it into your computer. So it's a detachable optical drives that you can just utilize it. Those are the ones where you can see a lot more application software. So for example, when you buy a Mac, right, you can just simply say, hey, I'm going to get a flash drive and install a Mac OS on it. Right? It typically comes configured with it. Versus, hey, if you want to get a productivity software or any of the photo processing software on top of the Mac, usually download it or get a flash drive and install it from there. So that's an example of how you would just see it in application software versus that.
I'm sorry, I just have an off topic, but a very curious question. I cannot stop myself.
Go ahead.
So like when someone is hacking, so do they also have to, like interact with the platform that you have, or
Yes.
Right?
Yeah.
Because just hacking into your software might not help. I'm just guessing.
Yeah. So when people hack, they essentially hack at the system software level. They usually walk in through the application software path into that, but then it utilizes the API in the system software to go and hack into it.
That's how they access your whole
yeah. Because think of it, right? So for example, when people talk about nowadays is more or less kind of malware where they just go and ransomware. Have you heard about ransomware? Probably you're in the finance industry, you're in FI, so you might have heard it. So this is where people take control of your machine and encrypt all of your hard disks or all of the data or files on the system. And then you have no way to access that unless you give them the money, and they will give you a key which will unlock those encryptions. Right. So typically they come through some sort of a backdoor on the application or a system security patch, then just goes through that. Because if you never connect yourself to the internet, there's no way for people to get into the machine, right? So they're never going to be able to hack it. But as soon as you're putting a connected device, which is going to be connected to somewhere, now you open a path for people to get into it, right? Because that typically happens through an application software, or sometimes, as I mentioned, right, the patches, right? Every so often, there is security patches, which is talking about, hey, the holes are open, and then do that. Right, so one of the most common is, if you look into it, is denial of service attack. That's what people do it, even into the people's home network. People can still like it's access the router through the denial of service attack and take over the router. So in terms of application software, their primary function is essentially to help with the productivity. By that means is any work that we are doing it, essentially it helps you to expedite it or get it completed. So when you're looking at presentation, right, it's a productivity that, hey, I want to like it's utilize it and make it much more effective so that everybody can see it instead of just a one screen. If you're utilizing photo processing software, right, the productivity is that, hey, the picture looks at this way, I want to change it to look this way. And then my computer software helps me to make it much more that. Some of the other example would be is like text calculation or insurance calculations, or in the commercial world, right? So if you're like it's doing online banking or going to Amazon and perform some sort of purchases, all of that's nothing but a productivity task. Okay. Again, the overall ecosystem, what people call it, just it's all three layers: application software, system software, and the hardware platform. Okay. Now let's talk about the different types of application software, right? So when we talk about the three layers, right, the bottom layer hardware is what is hardware. Okay. The middle layer is the system software, which is a lot more closely tied with the hardware. It has to have an understanding and the knowledge of how the hardware is done. So when you look into the software chip architecture, right? So when they talk about the processing units, there are two different types of architecture you can have. One is called as little endian, and the other one is a big endian. So it's essentially how it stores the number and how it processes the number, where the least significant digit goes first or it goes the last. Based on that, there's a two different architecture on that. Okay, you don't have to worry about that as a business analyst, but that's the primary reason why you see it, different types of hardware. And then on top of that, you're going to just go ahead and see the system software specifically. Nowadays, there is another flavor of the hardware, or actually two flavors of the hardware that started coming in, and that's where you're going to see it a little bit different application on top of it. One is known as a graphical processing unit. So a lot of image intensive AI applications, they're built in something known as a graphical processing unit. The other one is known as the quantum computing, which is kind of much more focused. So traditionally your software was always, when people call it, as a binary, it's a 0 or a 1. In a quantum computing, it is more than just the two states. The two state means 0 and 1. Quantum computing, it goes into specific state transitions. So that's where it is much more useful in AI, as well as in terms of a lot of machine learning and image processing, because there's only certain sets of state that it can take into it. I don't foresee in the near future that any one of you are going to be utilizing the AI computing, where you're going to go into the qubit computing. Okay, so those are the kind of flavors that we're not going to talk more about it, but we're going to talk about the traditional application software. So when you look into traditional application software, they are kind of categorized into three different categories. Okay, the one is known as the proprietary software. So this is typically a one-of-a-kind software, and that is kind of designed specifically by a given company and owned by a given company only. So when you look into iOS, right, and all of the configuration things that comes with the iOS or Apple devices, right? So when you look into, Apple has a OneNote, which is equivalent to PowerPoint presentation. You can't run that software on anything else. You can't buy it from anybody else. That's kind of an example of proprietary software, that it was kind of built by one company for a specific platform and a specific purpose. Okay. Another example of a proprietary software is, I'm kind of like, it's big into the science and space, right? So when you look into all of the rocket launching systems, right, that's not a generic software that you can do anywhere, right? So Tesla, when he builds it, when they build it, like it's any of the software related to the SpaceX, right? Those are specifically catered to the hardware and will work on one set of rockets only. It doesn't work on the other sets of rockets. That's an example of a proprietary software. Another category of software is off-the-shelf software. So this is the kind of software that you can actually buy it from a shelf and then go ahead and install it. So things that I talked about, if you're trying to do a photo processing, right, you can buy an Adobe Photoshop type of software that you can actually go ahead and install. It doesn't matter what platform you have. So it is not catered to a specifically one sort of application on one sort of hardware. Another example is Microsoft Office. A lot of those things off the shelf, they are now getting migrated from a device installed software to a more on a cloud-based software. That means you just install only certain minimal portion and the rest of all is working on a remote machine. Okay, so you must have heard the word like Azure or Amazon Web Services type of thing. Those are nothing but a cloud platforms on that. Most common example most of the people has heard about it is Apple's iCloud. Right. So those are the kind of off-the-shelf software that you can actually purchase it and just install it in any of the hardware, and it will still work its function. The third category is an open source software. So when you think of open source, this is the software that is kind of typically built by community for the community, and then you can utilize it for free under certain conditions. But you can also contribute to it and enhance it continuously. So as you go into the business analysis and software development world, there are a few common open source things that you will keep hearing about it. One example is the Linux hardware or a Linux operating system. That's kind of open source. You will hear the word like Red Hat, that thing. Another thing you will hear that is, hey, the software is built into Java platform. The entire Java platform is an open source. A lot of big Silicon Valley companies now get into a pattern where they build the software for their own purpose for that, but then they just give it out to community. So for example, if you ever end up building a huge social media platform like Facebook, Facebook has all of their entire distributed data management software out of for open source. You can grab it and you can like just install it and then run it across the servers across the world. Okay, so those are the kind of different type of software you're going to do it. And when you go into the commercial world, you may end up interacting with any three type of application software.
I'm not exactly clear about the open source software. So in that, any company or any person can just get the free version of it and then enhance it according to their own convenience, and then
So think about it.
So like Open Office, right? Then we have
Yeah.
Open Office is kind of free to use it. You don't pay anything to use it.
So think of this, okay? And this probably is a good example. What kind of phone you have? Android or iPhone?
Android.
Android, right? So if you took an Android phone, right? It can work on Samsung. It will work on Motorola phones. It will work on LG phones, right? So why? It's a different platforms, right? Different manufacturer, but it still works. because Google has built the Android operating systems and put it in open source domain. So any of the manufacturer can take that operating systems and they can customize, right? So because if you're using a Samsung phone versus you're using LG phone, or if you're using it, let's say with the AT&T carrier, or you're using it with Verizon, you're gonna have a little bit different flavor of it. But the underlying operating system, it's still exact same. It's performing the same tasks and same functions, right? So that's an example of an open source software that's customized for that. Now, there are certain limitations, but when you customize it, you can still sell the software. You can sell the services associated with that customization, but you can't sell the software. So that's the thing. That's free to use under specific agreements. Because what they don't want it is somebody making money from somebody else's work. Okay, so that's what it is going to be open source. So when you're like, it's going to build a Java applications, or when you're going to build, for example, MySQL database is one of the common things that you will keep hearing about it. That's an open source database software that anybody can use. So there are a lot of development tools, software development tools that are available in open source community. I don't know if you guys heard it, like it's when the kids keep doing it nowadays. And a lot of people when build the web applications, they talk about Python. Python is an open source software.
Scratch.
Yeah, Scratch. All of those are open source software that you can just download it for free to use. And if you want it, you can just go dig it into the software itself and go ahead and modify it if you want. Okay. Any questions so far? Okay. So let's get into, now that you understand what the software is, right? Let's get into understanding what are the different types of ways the software can be constructed, right? I'm not talking methodology, but like it's kind of architecture around it. Okay. So when you think about talking about any architecture, whether it's a hardware, software, or anything outside, right? One of the most common example that you can relate yourself in terms of architecture is the buildings, right? So the way humans have built the buildings over the last couple of thousand years. So when you look at the building, what it talks about, right? It has a lot of different components, right? So it has your frame. And so whenever you talk about any building, it has a foundation and it has a frame, right? You can't just put any frame on top of any foundation, right? There has to be some interaction point between the frame and the foundation that holds the frame together with the foundation, right? Then you go ahead and put an electric system inside those frame that essentially gives you the ability to go ahead and run the electricity across the entire house, right? It's not just random, right? So people can't just take it, hey, let me just put it and do that, right? There are certain ways that they say, hey, this is how the electricity is going to be wired inside the frame so that you can reach it across the entire house, right? So when you think about any architecture, it involves multiple components, and each component has their own purpose. Like so foundation has its own purpose, framework has its own purpose, electrical system that you run it across it has its own purpose. And so it's talks about any component, specific purpose of those components, and how those components interact with the other component to perform the overall functionality that you're expecting it from that unit, right? So even in the software world, it's nothing, a software architecture is nothing but understanding of the various components, how they interact with it, and what are the API in terms of communication protocols. So it compromises of software elements, the relationship between them, and the properties of those elements. So that's, in a nutshell, is a software architecture. Okay. So software originally started around 1940s, or a little bit earlier than 1940s. So early computers, or IBM has built the early calculators going back to about 1920s. Okay. But it took it a lot more off from 1940s onwards. Okay. So just like when you look into the houses and even the communication structure, right? When I say communication, I'm talking about the bridges and so on the physical structures, right? When you look into earlier, it was a very early stage, let's say wooden bridges. Then you will have some steel bridges, then you will have steel and cement bridges and so on. So when you look at it over the centuries, how the bridges is built has changed. Same thing with the software architecture, right? As the software development and the requirements around it is evolved and all the components that can, capabilities is evolved, your software architecture has also evolved. Okay, so let's take a look at about 5 different architectures that is, you can still see it in the current modern world. So in the original days, in the early 1930s and 40s, when the software was built, it was built with the mindset that, hey, everything needs to be together into one single unit, right? So when you think about code, so code is a common term used by most of the developers talk about what are the processing instruction is going to be, okay? And the data is essentially what are the inputs you're going to give it in order to perform any functions. So when you think about a calculator, right? So if I think a calculator, right? What are the common things in a calculator, right? So it's all the instructions, right? How do you do the additions? Those are like it's kind of stuck into the calculator, right? And the only things that constantly changes is the input that you provide, right? Whether you provide 2 + 2 or 2 + 3 or 1 + 8, whatever the input you provide. So all those things that you provide an input, whether it's 2 + 2 or 3 + 5, those are known as nothing but the data. Calculator operates on that data to produce the output. So in the very early infrastructure, you had no ability to provide variable data, right? So you just go ahead and load the data and then start the computation and everything does. So one of the most early example of this architecture, you can see it is, I don't know if anybody has ever watched a movie called Enigma. Did you watch after that?
I didn't got a chance to see that.
Okay. So it's the story around the Second World War, where the Allied forces, mainly British, actually built the machine to take the encryption code the Germans were using it to send it all the messages and decrypt it so that they can see what message they are sending it, so they can have an upper leg into the war. Okay, it was built by a gentleman called Alan Turing. It's still known as the father of the computing today. And it's kind of a really interesting movie if you're like, it's in any of those
Yeah, I think I watched it.
scientific things. Okay, but that's an example where they will take the deciphered code or a message that they get it intercepted, and they will plug in that as a data, and then they will run it this whole entire machine to get the output results. Okay, so everything is that. Most of the, I would say is that the self-autonomous systems where it doesn't take any external input are also built in stuff like this way.
Sorry, what systems?
Autonomous systems. So for example, when you look into the car manufacturing, right on the floor of those things, there are automated robots, right? They operate completely independently, right? So they have all the data in terms of where the the car is going to come in and stop into the assembly line, and then they have a code of what exactly they need to do it, and they just go run it independently. Nobody has to manually operate.
So it's all like predetermined.
Yes, it is predetermined, but it is kind of, it doesn't interact with anything external. It just, everything is in there in order to do that. So that's kind of a monolithic architecture. Unless you work on a dedicated closed instrumentation systems, you're probably never going to interact with this thing. And as the world evolved, most of the insurance company and the banking companies started utilizing the computer world. Okay. However, there was, as you go through it, there was a need, right? You can't have just one computer and everybody go to that place for banking all the time. So banks had a different branches, right? So people would say, hey, this is a very expensive equipment, right? And computer in those days were like filled number of rooms, so you can't just go and put it everywhere that you want it. But then you can't have everybody just going into the computer room, take a queue and do it. So they needed to build it and say, hey, this is a massive investment that we are doing it, and then we need an ability for more than one person to use it. So things got evolved into what is known as a client-server architecture, where server is your main computer, and that essentially interacted through a whole bunch of clients that were connected through remote connection. Okay, so the intention was those clients will send a request to the main computer, they will perform the computation and will send a response back to that client. Okay. So when you look into the monolithic architecture versus this architecture, now every time you have more than one thing, you add a complexity. Right? In monolithic architecture, you never had to worry about, hey, whose request is, and should I send the response to the same person or not? Now I have to worry about it. So if you're a business analyst and you're doing analysis in the mind, how the software is going to work or what function is going to perform, you have to now start worrying about the complexity. What if this guy sends a request? Right? How do I make sure the response goes to this person and not to this person? What happens after sending a request? I lose the connectivity. What happens to whatever the response is calculated? How that's supposed to go? Right? What happens if I send a request and this computer dies? What happens to my request? What happens to all this connectivity? So now you need to start analyzing it's, hey, what are the complexities going to be involved? And you need to start learning about those and asking questions because you have to build a software that's going to deal with those complexities. Then in early 80s, mid 80s, the computers has become a much more accessible with the notion of like it's Macs and Intel. Things came at where you can actually get it much more in a distributed environment. So the system started revolving and evolving around three-tier application. And part of it is also a realization that my computing doesn't involve just an input and a processing. My computing involves input processing, but then storing the information also. So if I'm a bank or an insurance company, my most important asset is not the computing systems. My most important asset is the data about my customers, right? So who are your customers? How much is the balance? Or what are kind of insurance they have it? Or what kind of medication and healthcare systems that they're doing it? So all those data is getting important. So they started separating it because they now needed to start processing the data, right? So it's different thing when I have only like it's 10 different customers. I can manage it, right? Keep it online. But when I have millions of customers, I need to make sure I have a ways to manage those millions of customer data. So the database management system started coming in, what known as the databases, whether it's an Oracles of the world or Sybase or MySQL type of thing. So this particular component is now responsible to just to manage the data, responds to the request and say, hey, give me this particular customer's record, or give me this order's information. So all those transactions are still kind of gone through everywhere, but the end results or resting data just needs to be stored here in the database. Your application tier is still involved at doing a business processing, right? So when you say, hey, if I want to it's kind of transfer our money from one account to another account, there is a specific business process, right? It says, hey, can I transfer it from one type of account to another type of account? And they can say, hey, you can do only if it is account type is this, or this, and you are allowed only to do certain transfers. And then if you do more than those transfers, then they start charging you for transaction fees. So those kind of rules are always going to stay in the application here. Then I'm going to have a presentation here, right? Because this is the time when things started coming into a different end devices. So if you are doing a banking, you could go into the mainframe or in the main branch, and they will have one set of interfaces. Versus if you go into the branch, there used to be a green terminals, right? Nowadays, if you go to the branch, they have a slick new, like it's iPad devices where you can just go put it, or you can log in from home yourself and then look at that. So that means I have to deal with multiple different presentations here because I don't know what the size of those screens will be. It could be different, right? So depending on it. So when you're trying to pull an email on your phone, the interface is going to be different than versus pulling the email on your laptop, right? So I have to start worrying about what is the presentation here and how that information needs to be presented from the system's point of view. Right? So each one has its own importance started coming. And this is the time when they started also realizing it is that, hey, my data is common, but my application may be multiple, right? So when you go to banking, right, your data about a customer is the same. They may have different types of account and different types of investment. You may have a separate application which deals with the investment, right? Dealing with how many stock markets, what they have it and that thing. You may have a different system that interacts about their savings and checking account, right? So I may still have the data commonality, but same data can be used by multiple applications.
So are these all tiers in the same server?
No, this could be on the same server, could be on a completely different server. But from the architecture point of view, you need to treat it that it could reside anywhere, right? So the connectivity going from an application tier to this, even if it's in the same server, you may have to maintain the same stack of going through the hardware layer and then come back for communication.
So when they are in the same server or as they're on different servers, does the output or the way you deal with it is different?
So typically, no. The reason why is because if you're keeping in the same server, what value you're gaining it from a monolithic architecture,
I mean, of course, servers are expensive and there is
right? So you're not getting any difference in terms of the business value if it is this architecture or if it is this architecture with everything running on the same server, right? Because what if this server crashes? In this case, it's the same server with this and this side, so my system is completely offline. Right?
so the connectivity is lost because they all three have to be in a sync.
Not necessarily in the same. I can still have database up and running, and there are two different applications running on two servers. One server goes down with one application, the other application is still working fine.
So everything doesn't come down at the same point if
Right.
if
So
it crashes.
the more the distributed comes in, it provides the two advantages, right? You can control each of the component independently. But at the same time, now you can leverage the information in a different way. And you can scale that differently, right? So for example, think of this way, right? If your foundation and your frame is built with the same thickness and they are very rigid, they don't have ability to do that. While you're building it, if a stone comes in, takes away the frame, I can still use the same foundation and build a new frame on top of it to do that. But if I build everything into rigid, so that, hey, everything is integrated so that one cannot exist without the other, and a storm comes in, I have to even rip the whole foundation and redo the whole thing. Right? Think of the same way. If I have multiple systems and for whatever reason, one gets impacted, the intention of breaking into multiple tiers is A, it can survive independently, and two, that information is of a valuable, right? So you just don't break the tier for the sake of breaking into different, right? That each one has a value because, as I mentioned, right, my data tier may serve multiple applications because it's a common data, because that's where my customer information is, right? You're not going to see customer information replicated by every system. So when you go to the bank, right, and you talk about, hey, I'm so-and-so customer, like every time you open an account, they don't create a complete new identity for you. They always identify who you are, and then they associate what all products you have, right?
Yeah.
That's the value of it, right? So now I know what is this. It can be used by multiple applications. Now, each of the application can be viewed through one or two or more gateways, right? Not necessarily every application has to offer you a mobile interface, right? There are some applications which says, hey, you can't access it from the phone. You have to be logged into the computer, right? So there is each value, but if I'm building a system that's going to be adapt to all of them, I have to worry about all of those interfaces. So that's one of the common things you're going to see when you build the system or try to identify the requirements around it, is to know it's how much adaptability that system needs. Is it going to be accessible from multiple tiers or multiple devices, or is it going to be same that, right? So when you, let's say if you're building a satellite tracking systems, nobody cares whether you don't build a mobile interface or not for that, right? Because it's not needed. For security purpose, they would just, we don't want a mobile interface. We want an interface that is dedicated to accessible only from the control rooms for those satellites. But if I'm doing it, let's say my home automation system, right? Let's say I'm putting in an alarm. I want to have that ability to see it even if I'm not at home, that alarm has gone off so that I can access it. So I'm not going to just put it a physical interface that is, but I'm going to give them a mobile interface also that gives me alert remotely and I can enable to access it, right? So that's an example where you need to start thinking about. But again, remember, think about it, how it was evolved, right? This was just around 80s, where you have now more computing devices are more affordable for the mid-sized companies.
And I believe like these days, most of the companies offer more than one product. So,
Hang on to that. As we go through Evolve, you will understand why this is different.
oh, okay.
Okay. So when you look into the older days, right, when the banks or any other companies, like even for that matter of insurance company, they will define the product, and you as a customer, either you buy it or you don't buy it. You don't have a choice, right? You pick whatever they offer. That's all you have. And things have shifted now. If you don't offer it, there's fine. There's some another person who's just starting up their business. They're willing to offer. I'll just go to them. The net result is if I lost you as a customer, then you're never going to come back, right? So even established companies are forced to adapt to those mindsets. You had a question?
No, I was talking on the terms like about this, these 3 tiers. It's like my company offers, insurance. They have the insurance product, they have the banking product,
Yeah.
they have the home, home loan, all those things. So one company is providing a lot of options to you. So the data of the customers.
Hang on to that. Hang on to that. It will answer you in a couple of days. Because you're trying to compare today's systems and today's mindset with what was in the 80s. Okay. So think of this, right? There are 3 tiers. My data is important, my business logic is important, and how I'm going to present that. Then came late 90s, right? Things known as an internet started becoming more popular. People started getting more connectivity from the outside the bound of the businesses. You started getting connectivity to the end customers. What that means is now I'm started having it not just hundreds of thousands of transactions, but millions of transactions happening on a regular basis. I had millions of customers who will be logging into from home, like Amazon, right? On a Black Friday, which will come here soon, they have to deal with it on upwards of millions of transactions hitting their servers at the same time. Okay, so when you look into this architecture, right, and when you break it down a little bit more on the hardware point of view, okay, so when you think about opening up a computer, right? So I don't know how many of you open a computer, but that was my bachelor's thesis and project. Was more about understanding everything on the hardware and then building on top of it. So when you think about a computer, right? So it has something known as CPU, or core processing unit, which is the processor which is performing all the computation. Okay. Then when you buy a laptop, right? So what you will get a specification, right? So it'll, or even the phone, right? What it'll say, here's the type of processor, here's the memory, and here is how much hard disk is, right? So think about it. So all that memory is known as random access memory, or a RAM. Okay. And then whatever you do at, like, in terms of what is your hard drive capacity, or like it's a solid state devices, right? So it's known as SSD devices, right? So this is probably, you will have something in the range of 8 to 32 gig, right? You will hear like it's 1 to 8 terabytes of hard disk. Then they will say, hey, you can just still also buy an external hard drive or a home network drive, right? Which you can buy it, like it's one of the most common is like it's Western Digital, like it's my cloud drive. So you can build a cloud type of infrastructure at home or network access device. So those are known as NAS, or network attached storage. Okay, and this is probably, I'm not talking about home, I'm talking about commercially, right? So when you look into the big companies, they will have network storage devices, which runs into probably, it's thousands of terabytes. Okay. So when you're thinking about it, and a CPU, if you read it closely, that they will just say, hey, this is how much is L1 RAM, L2 RAM, and L3 cache. Okay, so this will be probably in terms of kilobytes, and the level 2 will be in terms of megabytes, which is essentially not very much memory when you think about it, right? Your average picture nowadays, it's about like 8 to 10 megabytes, right? So if you're trying to keep it this memory only, like it's anywhere between like it's 1 to 2 megabytes, you know that it won't even hold a picture. But there is a reason behind it. So if you think about it, right, when you have information here in this memory, okay, this is typically accessed in terms of gigahertz, which is 10 raised to 9 second, right? So to access one instruction, it takes me less than a nanosecond if the information is in this. Because remember, CPU cannot act on its own. It needs to have the data fed in so that they can process it. So if your information is here, it takes less than a nanosecond. If that information, if I cannot store it here, right? Because remember, this is only upwards of like 3 to 4 megabytes only. And I need to get into a little bit bigger source. So this thing is now, typically it's some sort of 10 raised to minus 8 seconds. So it's 10 times slower here. Okay. When I go from here to here, this is typically 100 times slower. Okay. When I go from here to here, this is typically in a millisecond, which is 1/1000th of a second only. Okay. So every time I move from one location to another location, my speed goes significantly down. The rate at which I can access is a lot more slower. Okay. So your question comes in is why don't I just put everything here? Right? Everything will be super fast. The cost to do this 1 kilobytes of memory, it's probably $1 here. Cost to do this is probably your 50 cents. Cost to do this, it's probably anywhere between 2 to 3 cents. When you do this cost, it's probably fraction of a cent to manage that, right? So you can't have millions of records stored at this tier, right? It has to be stored like this way. And it's kind of one of the most common questions people ask it is, hey, if the black box is indestructible, why don't they make the plane with the black box material? Right? Thing is, that weighs tons. If you make your plane that much heavy, it will never lift from the ground. Right? The same way, if you put everything here, it will be so much expensive that you will never buy it. You will never have a business justification to buy that. So you have to break it down into that. Now, when you think about it, right? If I have my data here that we talked about in there, if I'm going to access this data, and if it's going to stay in this tier, and if I have millions of customers on a Black Friday accessing the same information at the same time, just imagine how many machines and how much computers I'll need it just to address that. Versus what if I change that, I don't keep it here or here, but I just bring it only when I need it. Because remember, not all million customer is going to perform the transaction at the same time. I may have a million customer, but on a given time, only 100,000 are ordering that particular item. So the rest 900,000 doesn't need to be brought into the system, right? I don't have to keep it cached. All I do it is I just bring it data from here to here only when it's needed. But if I just do it all the time, and if the response time is this much slower every time, my customer is not going to wait for more than like 3 or 4 minutes to get the page refreshed, right? They're going to say, this site sucks. Let me just go do something else. So in order to provide a high performance, they had to break it down, the data layer, into 2 pieces. The data at the rest, which is the database, can still stay here or here in a really slow arena. But the first time a customer accesses that information, first time you log in, they say, hey, you know what? I'm going to pull certain information about that customer from here, and I'm going to bring it here, where I can access way faster. Right? So from database, I'm going to get into something known as data access layer. So this is in the memory. This is actually residing into your physical devices or storage devices. Okay. So I bring it, the caches, just only when I need it. Now, when I do that, I introduce a complexity, right? What if this machine goes down in the middleware transaction? What happens to the data which was changed here, which is not updated here? Right, so I have to worry about data synchronization aspect, fine. But that's what it is. I also have to worry about it is when this layer gets full, right? Because it's going to have only certain capacity based on whatever your memory size is. Which data I drop it out first? So a lot of times they implement a different algorithm. So it's a last in, first out type of thing, or first in, first out. So whichever the oldest one came in, I'm going to drop that. Or you can implement an algorithm which just say, hey, least used, or the furthest in the time scale it's used, right? Because I know, hey, if nobody has access for 10 minutes, most likely the person is logged off or it's not going to perform a transaction. Maybe I can just move that data out and bring in the other person who is now accessing in order to speed up. Because then this is now operating into millisecond or nanosecond. Okay. I still have my business layer. the normal business layer, right? So it's like here. But then my presentation layer needs to now broken down because it's the same information that I'm pulling it up. So if you go into the bank account, whether you log in from home, your balance is still a balance, right? Versus if I go into the tailor and ask them the balance, it has to be the same balance, right? It's just that how the information is presented is a little different because I was looking on my phone, which is a small phone device, versus the tailor, which is looking at the full screen, right? So I'm going to define my presentation layer is going to be broken down in what information needs to be presented, right? So what data gets pulled up versus UI layer is how the data is presented. So this is what data, and this is how it's presented. Okay. So now by breaking this into it, now it allows me to build a presentation layer that can be used across multiple devices. So I don't have to rewrite the whole presentation depending on the type of the screens that it's going to access. I have to just have to build the layer such a way that it has all the information that's needed. And based on the user interface, it just pulls it whatever information needs it to be shown. Okay. So that's the architecture that started building it because now I needed to build a system which needs to scale it. Part of the other reason is also there is a distribution layer started coming in because of the internet. Earlier, everything was limited to my workplace, right? So if you go to banking, you had to go into the branch to do that. So I can build a dedicated network from a branch to my main data centers. But I'm certainly not going to do that for millions of customers home, how they connected from them, right? They are going to come through the common internet. So that means they're going to be distributed. That means I'm not going to have a control of the type of devices over which they're going to come. Right? I don't know whether they come on a phone, a tablet, or a device, right? Versus I knew always if it's a tailor, there's always this definitive screen that size was provided. Right? So that's part of the reason why it's drive this need for the architecture. That now I can become a much more flexible system of doing it. Okay, good with so far?
I just have a question. So when it comes to a business analyst, whenever there are changes or any kind of new technology or anything added, so it affects all the layers, or does it affect only till the business layer?
It depends on what is the requirements is, right? So, but as a business analyst, you need to understand it is what is the intention of your business and how the user are going to go in and access it.
So every time when there is a different, project or a different company, in fact, a client, you need to have a better understanding of the applications and
yeah, and sometimes application is not built. You are building the application. You are helping them to build the application. So you need to understand it is what is that they're looking for, or it's a requirement, right? So if you look into, I need to be careful, shutting some of that. If you look into a much more secure system, right? It may have a requirement that, hey, you can't just go and access it from anywhere. Right? For example, if you are trying to do a building access system, you can't just say, hey, people will access from their phone and do that. You want to make sure that they come to the building and interact with whatever the validation entry point is, whether it's a badge or scan your phone or scan your thumb, biometrics, whatever is needed to open the gate to get into it. Right? Then you need to worry about that. Then you don't have to worry about, hey, what if somebody tried to access from the phone and come in? Because that's not a valid case for that particular system. But if you just say, hey, I want to be able to, I'm building a new social media type of app, right? And I want them to have ability to access from any of the mobile devices. Then you need to worry about it. Like, for example, WhatsApp, right? It's mainly mobile application. Well, I have to worry about that. Could be work from tablets, yes. Now they started integrating with the Mac, so you can access from Mac and a website too. Right? But that evolves it. So you have to think about it, how the system is going to be used, how your user is going to be utilized, and what is the purpose for the business. Right? Based on that, you will be collecting all the information. And then you will now don't have to worry about how the system gets architected, right? So there will be dedicated system architects or developers who will be looking at based on information you provided, and they will come up with the architecture and say, hey, in this scenario, this architecture is the best way to do it. However, the reason why you need to understand what are the different types of architectures available, because then you can ask the pertinent questions to your end users or the business users and say, hey, what do you want in your system? How are you going to access it? How often are you going to access it? How many people are going to access it at the same time? All that information is going to be useful for the developer or an architect to build the architecture. Says, hey, if you think this many users at the same time, then I need to provide this kind of capacity and resources for system to handle it. That's where the architecture comes in. Okay.
So as a BA, UI and the presentation tier, it will always be a factor we have to consider.
Right. So as we go into later part of the course, right, we'll talk about it as there are specific ways. It's a specific process, right, that you need to think about it and ask it, right? When you're looking at the presentation layer, right, you're going to say what information needs to be presented. When you talk about the UI layer, can you show me how it needs to be presented? Is it going to be presented like this or this, right? It could be, hey, this particular button, should it be at the top or it should be at the bottom? That's the UI layer. Versus you ask, what happens when you press this button? That's a presentation layer. Right? So you need to ask those sorts of questions and provide the detail so that the developer or architect can understand how the behavior pattern is going to be for the systems. Okay. Good so far?
Yes.
All right. Then, as I mentioned, right, as the internet came, there is another side effect of it happened. So this is where you were talking about, what if like they offer different services and all. So think about it, Amazon, right? Let's take an example. When the Amazon came in, right? Now, all of a sudden, what happens is when you order a book online. So let's talk through the normal process, right? How do? You go log into Amazon site, right? If you're not logged in, at least you were able to still search the book. You find the book that you wanted, right? You put it into the shopping cart. The next thing you do is check it out, right? Perform a checkout process. So prior to Amazon, it was easy, right? I have money. I walk to the store, give them the cash. They don't have to worry about anything else. They give me the book and I'm done with the transaction. But now with the online, I have to worry about it, how I'm going to perform that payment, right? Most commonly used is credit card, right? However, you have a credit card issued by different bank. I may have from different bank. Kashmir, you may have different, and Ankur may have different. So now you have different people having a different credit card that's going to give a payment. So I need to worry about, well, how do I know that this card is valid, it's not fraud, and you're allowed to perform the borrowing of the money that you're looking to purchase this particular item for, right? What is that information is going to be? Mostly to the bank which has issued your card, right? And then that bank probably have a tie-up with either MasterCard, Visa, or Amex or somebody, which are more or less kind of payment processor gateways, right? So I need to, as an Amazon, I need to know which card you have provided. Based on, I need to go to that gateway and ask them a question. Here's the person, here's the card number, here's the amount, and here is the expiry date they're saying it. Are you allowed to take this transaction? And so, good. If not, then it flags it, right? You can't purchase it if your card is not valid. It has to give that money first in order to purchase it. But Amazon doesn't own the gateways. Amazon doesn't own the banks, right? So now all of a sudden, instead of me just walking in and giving the cash, Amazon has a dependency on somebody external, right? It's a side effect of the internet, right? Because I could offer it online for anybody, but I have to deal with now. That means I'm going to interact with external people. So that's one external. Second thing goes it is you purchased it, now it needs to be shipped, right? In the early days, now it's a different thing. Amazon have their own distribution and delivery channels. But early days, Amazon had to rely on United Postal Service, DHL, or FedEx, or UPS, right? So I had to interact with now those external shipping company to give your order so that, and get the information from there so you can track it. Hey, where is my order? Right? Because you can go clearly see it even today, where your order is when it's shipped. So I have to now interact with the external entities. But that also brings a business opportunity, right? Earlier for all logistics companies, somebody has to come and give the package to them and track it from there, and they had their own separate systems. But now they have to integrate with Amazon systems so they can provide that. So with the internet, the need came in that, oh, now I may be performing a service, not just only by myself, but I may be integrating things that is provided as a service by other companies. So when they do it, I have to think completely different way of building the systems, right? So think of this, that's where the service-oriented architecture came, because everything was centered around the services. So let's look at from the top to bottom of how this thing is going to work, right? So I'm an Amazon customer. I see it, everything on the screen, right? The book that I want to purchase it, or the book I need to search it, right? So I may have a process orchestration. So if you think about it, purchasing a book, it's a process flow, right? As I say, I'm going to search for a book, find a book, add the book to the shopping cart, perform the payment, select the shipping mode, and then send it, right? So there is an orchestration layer. So as I go through it, depending on the type of transaction you perform, and depending on the role that you play it, you have different process flows. And for each of the process flow is going to tie to some sort of service. So for example, when I'm looking for a book, I might be tied to a search service. It says, hey, let me give you a criteria. I give the author or a title or ISBN number. And based on that, I'm going to search the book and give you the results. That's all my service is doing, is providing you search results. I may have another service which may be providing just me shipping status. Another service that may be providing me the ability to validate the credit card, right? There may be another service when you just say, hey, give me the order status, right? So you will have different services. Now, each one of those services could be residing within your boundary, or it could be an external, right? So your orchestration flow, it's going to know, hey, at which point, what a service I need to call. Is it an internal or an external? Because if it's an external, there needs to be some sort of security transactions with it, right? Because you can't just go to any bank and say, hey, does Dilip has this particular credit card and what that, right? It doesn't work that way, right? People want the secure transactions. So you have to worry about whether it's going to be security. And if it's not security, even internally, you need to worry about something known as authentication, right? It is for this customer only, or for this transaction only. Because 10 people may be searching 10 different books. I don't want the book that I'm searching goes to you, or what she's searching goes to him, type of thing, right? So there has to be some sort of unique identification tied into it. So those services then in turns goes look into it, hey, if I'm searching on the books, or I'm searching on the multimedia devices, right? Because book could be now electronic book, or it could be a physical copy. It could be a DVD, right? Or it could be a video streaming service. So based on that, you may have a different component, right? You may have a book, you may have DVDs, you may have different types of components that the search layer calls it based on that. It may call more than one component to perform its own task. Okay. Now, then the last layer is an application layer. Now think about the banks, right? You talked about you work at the Fiserv, you work at the Safelight. Those companies are there for years, right? Like JP Morgan is around for over 200 plus years. They've done a whole bunch of investment in the different systems. As soon as the new way comes, they don't say, hey, let's just throw everything else and build completely new from ground up. Because it's just a different way to access or different services or different products that I may be offering. But I'm not going to throw the existing product or the existing way because not all of a sudden everybody accesses everything through mobile only. There are still people who goes to the branch, right, to perform the transaction. There are still people who pick up the phone and essentially order the trades over the phone instead of doing it from online. So I have to still cater to the existing thing. Also, guess where is most of the investment is? In the legacy systems, right? Where most of data is located today? In the legacy systems. So I still need to make sure that whatever I build it interface on top of it so that I can still leverage all of those information and all of those investments. So that's how they build the service-oriented architecture. It essentially allows you flexibility to go to any services. So everything is now modularized instead of doing everything as a large, right? If you actually go to the physical bookstore, everything is done in that bookstore. Versus when you do it online, it may span 3, 4, 5 different companies to do it. So I still need to provide seamless, but each one of them, I have to do it from a mindset of service because, hey, you know what? I may be offering only one type of service. So banks may be offering only the gateway services. They don't care whether it's an Amazon coming in or Walmart is coming in or Target is coming in from online to validate their transaction, right? Because they look at all of those as a different customers. So their model is centered around the services that they offer or products that they offer. But the other businesses may be centered around integrating the services that the multiple people offer and then do that.
So for them, it would be more like the client server.
No, it'll still be service oriented. I'm still providing a service. When you call it, I'm still integrating my service, right? So if let's say if I'm a Target, let's say JP Morgan Chase, offering transaction services to different clients, I'm still providing my service. I'm just interacting with them. And then I may in turn has to do it, right? Because when you do it, a credit card transaction, right? Not only you have to validate that whether the credit card is valid or not, right? You have to block that much money. And when the transaction fulfills it, you actually transfer that money to other bank, right? Whoever the Amazon or the service provider has their bank account with. So it's not just a client server, right? I may have to have a transaction service. I may need to have a transfer service. I may have to accept that money, right? Because if both the parties still have an account with me, I still need to take out money from one and put it into the other, right? If it's an external, I need to send the actual physical money type of thing. And obviously it's electronic transactions, but I still have to send those. Right?
So there's still complexity.
There's still complexity.
For them as well.
Right, those are still the services, right? So more and more you're going to see it nowadays is everything is getting centered around services. But if you look at it, right, the systems are still there at the bottom layer that I'm using it. So if you're trying to perform an enhancement in that system, you still have to worry about those type of architecture and how it's going to address it. Right? Then there is an API. Remember we said nothing but it's a different component and integration. Now my component may be broken down into multiple components itself, still acting as a one unit for newer sets of application. Okay. Then 2008 came around and Steve Jobs make it things much more easier for people to access it. Granted, Steve Jobs was not the first one to provide a mobile phone. There used to be what we call as a brick phone available from early 1990s to all the way to 2000, where the HP and a Windows-based phone were there, but it was not very easy to use it. But with the iPhone and the Android coming in, things becoming easy, people have started using mobile ways to do it. But the mobile brings its own challenges, right? Because you're not always connected. If I'm driving it 70 miles an hour on an I-70, I don't maintain a static connection with the one tower, right? I transition from a tower to a tower as I go through it. What happens if I'm performing a transaction in between the transition? What happens? I may lose the connectivity. How do I deal with my transaction? Do I have to restart from scratch? Some transaction I may have to. Some transactions just get suspended and gets reestablished as soon as you get connectivity to the next tower, right? Same thing. Now I have to worry about it to synchronization point. When was I last connected? What is the state of data on my phone? Because not every time you get an email, it always goes to server, right? It downloads it, keeps it in your phone. So you can access offline and respond to it. And as soon as it connects, it always sends the response. So that means I need to have some sort of mini storage capability on my phone, right? That's where you see an application taking up so much space in each of the phone data, because it's storing all those data associated with that application, right? But as soon as I connect it back, I have to synchronize with the master, wherever my mail server or wherever my Facebook account or my cloud account is there. So I have to worry about infrastructure for that. Not only I have to worry about the server, right, wherever the business is located, but if I'm providing an application for my customer to access from a mobile device, I have to worry about now synchronization and making sure the data integrity is maintained between this and this. Okay, so that's the mobile application. I have to worry about connectivity, I have to worry about synchronization. And sometimes I may be suspended for a long time, right? Because what if, like, it's, hey, I kind of went into an area where there's no coverage and I was there for like 2 hours. Okay, make sense? Do you understand how the architecture evolved over the years and what different types of complexity as a business analyst you need to start thinking about it? Because my requirement has evolved, right? Earlier it was, hey, I will go to the bank, customer will come to the branch and we will perform the transaction, versus now they could be anywhere, right? And the type of services they can perform or not, it's going to be different. Let's do a quick 5-minute break. Like we are like an hour and 40 minutes into it. We do a 5-minute break and then we'll continue with the overall development cycle. How is software built now? Okay. So it's 10:37 for online team members. We'll take about 5-minute break. We'll start about 10:42, 43. Okay.
Do you guys prefer the
Thank you.
print out?
Whatever is easy for you. I mean, I would say print out. Yeah. And where are you basically from India?
Mumbai.
Oh my God, we were just talking about India.
Oh, really?
Yeah.
Are you from Mumbai too?
Yeah.
Where
I
exactly?
bought up in Mumbai.
Where from
Borivali.
Mumbai?
Borivali.
Oh.
I did my under the junior college from Parley,
Okay.
and then my engineering from Father Agnell.
From where, sorry?
Father Agnell's.
Okay.
Yeah.
So,
Was telling it's like my age shows probably with the hair. But when I used to go to the college, there was nothing, and there was kind of completely nice open Father Agnell ashram. There was no Mannat, there was no other building. It was nice and clean. There was only Sea Rock, no other hotels. You can clearly see the sea.
so Father Agnell Ashram also has engineering college in it?
Yes.
I didn't knew
It
that.
was,
And I've been there like so many times.
yeah, that one. So it was this third private engineering college in Bombay. So after VJTI and SP, which are the two government ones, There was a Tadamo, Father Agnol's, and the one in Churchgate, the Casey Engineering College.
Oh, yeah. I mean, I'm from the Churchgate side, so, but I've been to Agile
Yeah.
a lot of times, so.
We'll have a kind of Mumbai session one day, talking
And
to
where are you
multiple
from? From
activities. Well, back in like 8 years ago, I did my internship from Mumbai too, because I did my MBA from Pune. So I was like on and
I'm
off.
from Pune.
She's
Yeah,
from
there you
Pune.
go. There you go. I did my MBA from ICFI,
Oh, I
ICFI,
did from Pune University.
Pune University.
Yeah.
Was it for Shivajinagar? Because basically the main campus is at Shivajinagar, right, for Pune University.
Yeah.
Yeah. Cool. I spent like hardcore 5 years in Pune.
Oh.
Well, like, sorry, Dilip, if I like buying my time. Okay, coming back to the session, yeah. We'll take it over.
We'll use the other break.
Yes.
All right. So everybody back online? Right. So now let's talk about how the actual software is developed. Okay. So if you think about it like it's a house, right? So whenever you're building a house, right? So it goes through the life cycle, right? So you plan to build a house, then you actually go through the construction phase, build house, you make sure all the features in the house works as expected. Then you go into the maintenance mode of the house, right? And at some point, you essentially demolish the house, right? So this entire thing called a life cycle. Software development also has a life cycle, right? So you will hear a more common term called SDLC, right? So as you talk about, as engineers, we are much more fond of it's abbreviating everything, right? So the SDLC is one of those. So just like a house building, right? You have a entire dedicated life cycle that happens around the software. Okay. The first time you envision the need of building a software, right? So that's typically it happens in the planning phase. Once you determine that, yes, I do want to build a software, then you get into, well, what should it look like? What features, what capabilities it should have, right? So similar, if you're building a house, right? You said, hey, I want to build a house. Great. The first question is, well, what type of house you want? Do you want multi-story single family? Do you want a townhome style? Do you want a ranch home style? How many bedrooms you want it, right? What kind of other features and upgrades do you want in the house, right? So all those things are nothing but the analysis phase. Same way in the software. Well, what are the features? Who all should be able to access from where all they should be able to access, right? So that's where it comes in, right? This is where you will play a significant role in terms of, as a BA, to mold what the software will look like. Then it comes into, once I know what all I wanted, then it's time to design, right? So for example, it's in the house, once everything is kind of defined, what is the first thing the contractor does, right? They create a blueprint, right? And run through the county and just say, hey, is this blueprint okay? Same thing, right? You start designing. What are the different components should be? What kind of architecture, software architecture need to be? Does it need to be a service-oriented architecture? Does it need to multi-tier architecture? Does it need to be mobile? Or a combination of it? What type of architecture I need it? Right? So what are the different components? What should be the function for each of the components should be? Then you go into implementation phase. This is where you're actually developing the software, where the team is writing the code to build the behaviors that you're looking for in the system. Right, same thing. Contractor gets the blueprint approved, then they actually build the house. Then you go to testing, right? Well, when I plug in my device, is there a current coming in? When I turn on the faucet, is the water coming in? Is the drainage working in? When I walk it, is it able to sustain the weight? If I go into third floor, and if the starts collapsing from the weight, that's a problem, right? So does it work as expected? Does it work, software works as per specification, right? If I'm sending in information to transfer the money from one account to another account, does it work as expected? Or it takes out the money from one account and doesn't get into the other account, how many people will be happy with that, right? So ability to test that feature and functionality. Once you test it, then it becomes an acceptance, right? So if you're building in a house, right, you give the down payment, but you don't give the actual money till actually the house is working as expected, right? That's only when you, or a bank, whoever is writing the check, will write the check to do it. Same thing in the software world. Unless everything is working, people are not going to accept it. You may think you build a great system, but it's not fit for the purpose. The business is going to say, this is not going to work for me. They're not going to pay for it, right? And then goes into the maintenance mode. Once it's working system, goes into maintenance mode. Once I'm living in the house, it goes into maintenance mode, right? I'm not building any new things. I'm just living and using it, okay? And then there may be, hey, I want to add a new feature. I want to build a patio, or I want to build a pool, or I want to, like it's develop a basement or finish the basement, right? All those are new features, right? Whenever that comes in, you start with planning, right? Do I really need a patio? Well, how big a patio I need it, right? Does it need to be stone? Does it need to be wooden? What kind of things? Go same cycle. Adding a new feature, you go to the same cycle for the software. What additional capability you needed, why you need it, what it would look like, how does it integrate with the rest of the things? Okay, so that's the software development lifecycle. That as you look through it, you have to realize it through the entire lifecycle. Then there is a concept called software development methodology. Okay, so think about it, right? So if I kind of identify, hey, I want the 2-story building or house with 4 bedrooms, like 3 bath, kitchen, and a patio. And that says, these are my requirements. And if I give it to 2 different builders, do you think they will build the exact same way? Probably not, right? Even if I come up with exact same specification and give it to 2 different people, probably they're going to take a little bit different path in building it, right? Somebody may build it, the foundation and the framework first, but then one person will put the electrical system first, other person will put the water system first, or like plumbing system first, right? They're each going to have a different ways to approach it, but they may still produce the same final output, right? Same way in a software development world, there are like it's 2 or 3 different methodologies people use it to build a software. They may still ultimately produce the same feature, same capability of the software. So each path is known as typically a software development methodology. And just like anything else, there is always pros and cons for each one of them. One is more suitable for one type of thing versus other one is more suitable for different other type of things. So let's talk about those. There are 3 main systems or 3 main development methodologies. The one is known as Agile. Other one is a rational unified process, or what it's called as a RUP or iterative. And the third one is a waterfall. So let's start with the one that is kind of more commonly used in the current world. Okay. So a lot of companies have now started shifting into this Agile development methodology. But the purpose of that is traditionally, when you go to any big software development firms, right? There was a saying that anything that you're looking for that will cost years and millions of dollars before you can get anything out of it, right? But with the internet and with the way that the marketplace has evolved, right? The customers are demanding things much more quickly and much more frequently, right? So the example that I gave you earlier, right? In the 90s and 80s, right? The bank will come up with a product, financial product, and then sell it to the customer and says, this is the product, You have no choice, you have no say in terms of what the product is going to be. They give you, and whether you get it or you don't get it, whatever you need it. Fast forward now, right? I have a college going teenagers. They don't even use the normal bank account. They use something called as Venmo, right? Because they provide the feature that they wanted, right? I don't have to worry about writing the checks to my friends or my roommates when we need to perform transaction. We just do it over the phone, boom, 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 it's gone, done. Like, think about it. The traditional banks, if you would have gone to them and says, hey, I need this kind of product. First of all, they will just say, okay, we will define the product for you. And it will take like 3 years and to do that. Right? The time has changed. Customer going to say, either you provide what I needed, or if you're not able to provide it, let somebody else provide. I'll just go take my business there. Right? What that forces is that I can't wait it for 4 years to build it. I needed something going out quickly, sometimes every day. Like if you think about it, the Amazon Web Services platform, or even the Facebook. Facebook performs a release every hour across the world. So they're building new features and releasing new feature every hour. You don't even notice it many times. Yeah. Right? But they do it on a daily basis. So it's a mindset is that, hey, I'm going to do it incrementally. But more important, the reason why it's getting adopted is from the financials point of view. If you think about it, if I'm going to put an investment to build it, and it's going to take me 2 years to build it before I can release that system for user. So for 2 years, I'm not going to get any financial benefits or return on my investment because the system is not available, right? But I'm still employing developers to build that system for 2 years, right? So I'm constantly spending the money. What happens after a year? If I find it out that my customer doesn't want what I'm building, and they want something else. Now I'm throwing that entire 1 year worth of investment out the door without getting any return on investment. That's a huge financial impact for the companies, right? So they need to start getting into it. And part of it is that this methodology started from a small firms because they don't have the money and the capital to survive for a year without getting any return on the investment. They had to do it as incrementally they do it, right? So that's what this Agile development methodology is. Let me give you an example that you may relate a little bit better. If I'm building a tax software, right, it's a complicated system. Right? If there is it's individual tax returns, there is a joint tax returns, there is a itemized, there is a standard, depending on what dependents, depending on 500 different type of schedules that the Congress keeps throwing out every year, right? So building a tax calculation system, it's a really complex system. Takes probably 2 to 3 years to build it. So if I say, hey, you know what, I'm going to get the system completely and then give you that. What's going to happen is I have to put in investment for 2 years. And by the way, Congress changes law every year. So halfway through it, I have to say, okay, some of the things that I built is no longer valid. I need to redo it. And I'm going to redo it, right? So it's going to take more time. And it's required significant investment. Versus what if I make a little bit different way? It says, yes, I want to build the tax systems, but I'm not going to cater everybody who needs to do it. I'm going to just focus only on those people who file single and who file non-itemized, or what's something known as an easy return. I know that out of 300 million people in US, only 2 million people are going to use that because that's the only people who fall in that category. But think about it. I can build that and sell that to that 2 million people and start getting some return on my investment. And I can get the feedback. They said, hey, you know what, this law changes, right? It's easier for me to do it because it's a very small module. Then I can just say, hey, let me add it now. It's standardized 1040. Then let me add it into 1040 where people can find jointly. Then, right? So every phase I can keep adding it and I keep increasing my customer base potentially from where I can sell it and start getting the money. I don't have to wait for the entire thing to be built to start getting the money. right? If you keep that mindset, that's an agile. Right? So I'm giving you incremental value. At the same time, getting the return, getting the feedback so I can make it my software better for it. Okay, so that's what it is. Where you have a vision, hey, I want to build this tech software for everybody. But then I'm going to take a first slice and in a predefined iteration period, which is typically between 2 to 4 weeks, I'm going to go ahead and build it. But within that, I'm still going to follow all those paths that we talked about. The requirements analysis, the design, implementation, code, test, and deploy. So every 2 to 4 weeks, I'm giving some value out. And then I'm picking, okay, let me get the next valuable slice. And then I add that. Then I add on top of it. That's an agile methodology. Yes.
So when we built it into steps, after we are done with a certain step, like first step, is it still usable?
Yes.
Is it ready to use?
I actually deployed. I actually ship it out.
Okay.
Right. So the people who are just filing the 1040 easy tax return, I sell them. I may be selling only like for $10.
Gotcha.
Right? But I'm getting it like if 100,000 people buy for $10, I got a $1 million return on my investment. Right? It may not cover everything that I invested, but let's say after first iteration and after selling the first thing, people say, the product sucks or it's too complex. It's going to take way more money than what I was thinking and don't want to build it. That's fine. You didn't lose all the money. You made some money back. Right? So that's that. Also, you don't wait it all the way till spending millions of dollars in 2 years before figuring out the customers don't need that product.
Also, like after first iteration, if it's successful, the first step that you've provided is successful, does it like become the base for the next one? So that all
Yes.
you have to do is like enhance.
So enhance or add a component, add a new features, add a new features. Okay. There are a couple of things and we'll talk a little bit later. Let's think of this way, right? Sometimes it's not very easy to build or enhance things on it without rewriting, right? So for example, you can take an approach in the house building and say, hey, you know what? I'm just going to build one room, then going to extend the second room, then going to extend the third room, right? If you did not think out properly of how the plumbing systems get extended or how the electrical system gets extended, you may have to rip the whole plumbing system and re-put it, joint and a whole bunch of things, right? So if you're building only one thing at a time as you go through it, and if you're not careful, then you may have to redo some of the things, right? If you're careful, your redo work will be minimal, right? So if I'm building a pool, but there is no pipeline going in, I may have to break it and I have to build a pipeline to fill the pool as well as to drain the pool, right? Versus if I put a extension and left it out there, so it's much more easier for me to build a pool in the future, right? So same mindset goes in, as you can build the iterations, but you have to think about, that's what I was talking about, some of the modern engineering practice. It's known as adaptable architecture. Because you don't know what the future or what are the features that the customer may request that you will build it down the road. So you need to make sure that your architecture is flexible to deal with any kind of changes that may require in the environment. Because if I build this portion and say, in order to build this, I have to rewrite this whole thing, I'm not going to get any value, right? Because I have to redo the whole thing. It's going to cost me twice the time and twice to do that. So that's an agile, and we'll talk about in much more detail of how it works in the next week's session. But did you guys get an idea of how the agile works in building it and the value that it brings it? Okay. The second type of development methodology is known as a RUP development methodology. This is essentially called RUP because it is extended from what IBM used to build what's known as a rational unified process. So IBM had a development methodology and to build a large scale systems, and that's what people started adopting into it. So when you think about the satellite tracking systems or rocket launching systems or things like building a new aircraft, like whether it's a Boeing is building 777 or 787 or US government building F-35 systems, right? Some of them are huge systems, and it requires that has to be built in much more incrementally instead of one big bang, right? So when you look into a perfect example, right? So Elon Musk is trying to build a system to go send humans to the Mars, right? If you think about it, he's using Agile as well as a iterative method in terms of building it, right? What did he do first thing? Hey, I'm going to start launching the satellite, right? Well, but I need to reduce the overall cost. So I'm going to figure it out how to get the rockets back and land it back. Once it deploy the satellite, I want to get rocket back into it. Then he's talking about incrementally go to the space station, right? So SpaceX can now send the humans to the space station. The next step is then, hey, I'm going to go increment that and go deploy the moon base. And then from moon, I'm going to go to the Mars. Well, in order to do those things, right, he has defined the phases. But within each phases, right, you can't just go and put the rocket straight, right? You have to test out the engine systems. You have to test out the software rocket tracking systems, and you have to test out all the landing systems, right? So you have to break it down that into smaller iterations. Within sending out a rocket, I have to test this 10 different things. Well, that's when the rub comes in, right? So they try to do it. This is what my goal is, right? So if you look into it, it has 4 phases: inception, elaboration, construction, and a transition. Okay. So the inception phase is where, hey, I'm going to put together a vision. But in order to do that, I need to build a little bit of prototypes to figure it out how everything will connect it, what it will come. Is it even feasible to do those things or not? So you're going to see it in the inception phase. There's going to be business modeling. You're going to do the requirements, but then you're going to do a little bit of analysis and prototyping to build it, right? So this small thing is talking about the building those prototypes and says whether it's going to connect or not. Then you're going to get in an elaboration phase. Now I know it's a feasible idea. Let's break it down. Let's get each of the component and says, how are we going to go to that? How are we going to make everything work and connect together, right? So for that, you're going to do a lot of additional requirements, a lot of analysis and design work. You're going to do it. But then you may have multiple iterations within that elaboration phase. Hey, let me just make sure, can I go from here to moon? But then can I extend that system from moon to Mars? Because going to Mars is one thing. You have to bring back the people, right? So all the infrastructure that you have it here to launch the people of the planet, it's not going to be there on the Mars. Or you need to build that first before sending anybody so that they can come back, right? So those are the kind of things in elaboration. And once you have figured it out, goes through simulation, through prototype, then you start building it, right? And once you build it, you test it. Now, the more realistic thing is when you build a big project, like it's, so Boeing uses the same methodology to build a 787. It's building a brand new plane, or right now it's 737 MAX, right? When you're building it, there are a whole bunch of things. You not only just tested the plane, but you also test the hydraulics, you test the landing system, you test the communication system with the control towers, you tested how it's going to communicate with the other plane so that it doesn't collide, right? All those components is there. I can't get everything into one big bang, right? I need to first make sure, hey, the communication systems within the aircraft, the main control tower is working fine. I have to build that, test that, working that. Then I have to build the second component. Then I need to integrate all of that and then do that, right? So it's an approach where, hey, I'm building it in individual components, but I'm still can't fly the aircraft till all of the component comes together. Make sense?
Oh.
Versus in the previous case, hey, I build a small air taxi or drone and I can fly that and get the value out of that. Versus this one is, yeah, I can build an engine, but that engine is not going to get the value till it is connected to the plane and plane takes off, right? So that's where this thing comes in. But again, I don't have to know everything about the engine. All I need to know the interface about the engine with the main aircraft. So that engine can be built by somebody else, aircraft can be built by somebody else. That's the understanding of getting those analysis and design and prototyping, how it's going to come together.
So the planning and designing is in steps, but the return on investment is,
It's one big,
it's one.
Check.
Okay.
yes. Nothing till you get transition or go into the production.
That's the only difference between the Agile and Rock.
Yeah. Precisely.
Agile can be used in the different, once the
Right.
itinerary is used.
Plus, this phases could be months, not weeks, as what is Agile talks about. That's a key difference, right? So if you think about it, right, so your planning may still be, or deployment may still be in the phases. So like, for example, the SpaceX talks about, right? My goal is to go to the Mars. But I can start getting the value as long as I can start launching the satellites. Get a return on that investment, I learn it, bring it back, and then I go to the International Space Station, learn it, get money from there. Then now I'm going to build the moon phase, and then I will go build it to the Mars phase, right? So there's still incremental phases connected to the big plan, but each of those phases itself involves multiple components. That's not going to add a value till all of those components comes together.
So there's companies who still use this.
There are companies, so whenever you do the big projects, there are still does it. For example, again, I don't know whether they used to or not.
Ohio still uses this, I think, right?
There are a lot of companies uses it, right? So like it's when you talk about the healthcare, when Obamacare was rolled out, right? I don't know what the systems behind it was used, but that could be a potential use of how RUP could be built. Because it required integration with the doctor systems, it required integration with the insurance system, required integration with the drug manufacturer. So there was a whole bunch of other integration that was really required on that one. Okay. But do you guys understand the difference between the Agile and the RUP? There are unless you work for a big firm, not many of them are going to be using RUP unless you work for a big giant project. Okay. And the third one is waterfall methodology. Okay. So think of it in a traditional world, right? So let's go back to the example of house building. Right? So the way typically house building works is you put together all the requirements of what you want in the house first, right? For a commercial building, whatever you're trying to build it, you have to put all the requirements first. You give the requirements and then they're going to say, it's okay, let me design based on this thing. And then once they're designed, then they're going to go into construction phase. But while they are in the design phase, you can say, hey, you know what? Instead of just the 2 bathrooms that I was doing it upstairs, I want 3 bathrooms. Right? What they're going to say is, wait a minute. I can't just simply add it. I have to go back to that drawing board and I have to design it and make sure everything fits it as it's needed, whether it's plumbing system, electrical systems, sewage systems, all of that, right? So I can't go back. I have to go back to the step 1 in order to proceed. What if you waited till they started building it and then told that? Then said, well, wait a minute. I have to hold it. I have to go back to my analysis phase to make sure what else is going to be impacted. Then I have to redesign it. Potentially I have to break some things and redo it to do that before I can come back to the phase, right? So that means I can't proceed to the next phase till I'm done with the current phase. And I needed to know everything up front before I do any work, right? So if you take the same mindset in the software development, if you go and say, hey, you know what? Put down all the requirements of what do you want in the software before I can do anything else. So I'm going to go through a huge requirement phase where you list out everything and anything that is required in the system. Then you go start doing a design, and then you start doing an implementation. At any point, if they say, hey, can you add this feature also? You say, let's put the break. Let me go back to the drawing board. I want to make sure everything else works as fine. Then I have to do that. Okay. If you use that mindset, that's known as a waterfall. Okay. So in other words, I want to know every requirement first before I build the software. Then I do the design. So for example, if you just say, hey, you know what? I want this systems to be accessible from my branches only. Okay, you start building it, and then some point customer comes back, you know what, it would be nice if I don't have to go to the branch for that. I can just access it from my home. And you say, wait a minute, that's going to change drastically. I have to redesign, re-architect everything. Let's go back, let's understand what all you wanted, right? That's how typically the software was built till early 2000s. Okay, you go through it. So that's why we were talking about anything you wanted takes years and millions of dollars to build it. That's how the mindset was set it up for the business. Okay, because they were trying to like just say, hey, you know what? We don't know what all, because it's still a science. It's not, so building a software is a computer science. It's not a computer engineering. It's still a change every system to every system. It's a science. So I don't know, when it's science, you don't know how long it will take you, right? If you go to the doctor and says, hey, doctor, I have a flu. Can you tell me exactly how many hours it'll get over with? They can't, right? Because science is going to be different. They said, I can give you a range. It may take 3 days to 2 weeks, but I can't tell you it'll be done second day or third day or fifth day. That's how the software was used to be built. I know you want this. It's going to take like 6 months and it's going to $5 million to build it. And anytime you ask for any change, well, it's going to cost you more, and it's going to cost more time to do it, right? Because the mindset was, I'm going to do the requirement analysis and do it. And every time any change comes, I'm going to go back all the way at the top and restart it, right? So all of my activity is going to flow like a waterfall. And if you're taking a water at any point, you can't just put it here and then restart, right? You have to move it back for it to start flowing it again. So that's the mindset, that's the waterfall. So that was typical. Remember when I was saying, I'm building a tax system. It's going to take me 2 years to build it. It's going to get me this much money. And if I build it to get everything out at the same time, this is the approach that I would be using. Okay. The downside is, till I get the deployment, I don't get a single penny of value. And I'm still doing investment. At any given point, if I scrape the project, all of my investment is gone. It's a waste of money.
And even if you add something, the delivery time will be
Right, it will get extended.
increased.
Now, again, even if you add something in Agile, remember the delivery time is still going to get extended. But you are getting incremental value at every phase or every step instead of waiting till the last. That's the key difference. People often will tell that, like, because one of the things I do it is in transformation is get the people transition to Agile, is people always say, hey, you're doing an Agile, therefore everything that you were building in 2 years, you can get done in 6 months. No. All it does says is whatever it's going to take time, it's still going to take a time. But the 70% of extra fluff that you are building in the systems, you're cutting it out because you're building only what you need. Therefore, at the end of 6 months, you will be saying, oh, I got 90% of what I wanted. I don't need to invest any more money in this.
It's also much more accurate because it's been through so many iterations.
Right. It's a continuous refinement, right? People talk about Agile is no planning. I tell it Agile is continuous planning. So you're refining it at every sprint, what I needed, what's next type of thing.
So how different it is when it goes to software wise, from waterfall to Scrub up to Agile? Is it like completely different? If you learn one, you have to learn another one, or is it something?
So if you think about activities of the phases that you do it, right, from planning to analysis to design to implementation, all those activities you have to do it irrespective of which of the three methodologies you use it. It just depends on how often you do it and how much you do it, right? So in the Agile, you don't worry about designing for the whole 9 yards. You're building this small component, let me just focus on designing that component. And the key aspect there is when you design it, you have to think about how I will adapt to it and how will I merge it into a bigger vision. That's why you need a vision first, right? But once you have a vision, you don't need to know all the details. You can do analysis only on a small portion, get that done, implement it, and then pick the next portion, and then pick the next portion.
So while I
So-
was, oh,
Yeah,
so
go ahead,
sorry.
go ahead.
So while I was reading you, like, normally like reading about waterfall and agile, how true is that? So waterfall is all about like system as a whole and agile is as part of the system? Is that correct? No.
No, it's, so when you go into more deep, there is a lot more deeper science in terms of what is known as the system thinking and all.
Mhm.
So there are a lot of things comes into play. The basic fundamental difference is the mindset, right? One mindset, like it's when you do a waterfall, I need to know everything in order to be effective in building this one.
Mhm.
Right? That's the mindset. I have to have the whole thing. I need to know everything what you wanted in order for me to give you even this small thing. Versus the agile mindset is, I understand the vision. I don't need everything. All I needed is this thing. So if you cook, right? Let's say I take an example. You're making a meal, right? You make different things for the meal. Let's say I'm making a pasta, right? So you make the pasta, you make the sauce, you make the garlic bread or whatever else you need, right? Or salad with it. So think about it. When you're making a sauce, do you need to know what else you need to put in the garlic bread to make garlic bread? You don't, right?
Just concentrate on-
You have a vision that, hey, I need to make an Italian meal,
Right.
right? But when I'm making a sauce, I have to worry only about that. When I'm boiling the pasta, I need to worry only about that. I don't need to worry about other. That's the agile mindset. I know what all I needed to say, but while I'm taking care of the first component,
Okay.
I don't need to worry about other things. Get it?
Yeah.
Okay. That's the agile mindset. Versus if you say, hey, let me get you the whole menu, what all you needed, how you needed, and what you needed. And it's waterfall.
So, sorry, again, getting in more in depth, if you say, like, we had to restart the waterfall process, okay? If there is any additional feature that we're trying to add, and let's talk about Agile in a similar manner. So almost like if we are trying to add something or maybe like, modify something, is there any unique way that you can like better explain us what is the basic thing that we need to make in mind to make us more familiarized about waterfall and agile? Because to be honest with you, I have a book reading in my mind. What exactly is a waterfall? What exactly is
As I said, it's a mindset.
it's a mindset. Okay, I know, yeah.
One thing I will tell you based on throughout my career as well as
Sure.
like I've been kind of in the teaching, I've been in the executive roles, and I've been kind of right now mentoring all the executives in that role, right?
Sure.
All you have to think about is a mindset. If you go with the preconceived notion that, hey, it has to follow the cookie cutter template, and I need to understand what that template is, you lost the battle right there.
Oh,
Because A, you don't know how the market is going to evolve.
Mhm.
Two, you don't know the capabilities and skills of the people that you will get it,
Mhm.
right?
Mhm.
So you have to almost cultivate it as in terms of it. In a lot of those things, skills, we'll talk through it in this business analysis. You need to understand the why behind it. If you're building this waterfall, may not be wrong, but why you're using it, do you know it? Right? If you don't know it,
There's no point.
doesn't matter what template somebody gives you, right? So if I give you a recipe for cooking, and you're just blindly following that, if it's not precise enough, do you think you will get the outcome that you're looking for? You won't, right? So that's the main thing you need to do. You need to have some sort of mindset and just say, hey, what I'm doing. Now, if the same cooking, let's say you're boiling pasta, right? And you boil it, first time you overboil it, second time you keep it undercooked, right? And if you, every time you boil it, you keep doing the same thing, are you learning anything? You're not adapting anything, right? So to me, you may still be trying to pretend that you're following Agile, but if you're not learning anything and integrating into it, there's no value in it, right? Versus if you're incrementally knowing it and applying the learnings from one phase into the second one and third and so on, you're continuously making your product better and making it more adaptable mindset. It has to be a mindset. You can't be just, hey, I needed this template and so on.
But I also think it also depends on the budget of the company, what they are aiming at. This example keeps coming to my mind. Like if one country is at war with another country, it is like a very big picture. So you need to know all the resources you have, and you need to know like something like waterfall. That is what comes to my mind. But when there were like small warriors who made it difficult for the British regiment to like in Maharashtra, Shivaji Maharaj, if you know. So he used to contain or wouldn't let the British regiment pass through certain difficult hilly mountain
Right.
areas because he used to deploy all his soldiers. He used to focus on that particular area, and British regiment could never get past that point, and they could never defeat that that king. So I would like to think it like
So,
Agile is focusing on small
no, not necessarily. So
at one time.
those two has nothing to do with the Agile.
I don't know.
It's the execution.
I just let my imagination.
It's the execution strategy, right? It's the execution strategy, right?
Yeah,
It's how much resources you have it and how you're
Yes.
deploying that. That's an execution strategy. Agile is not more about execution strategy, but it's more about taking that and to say it's, hey, so if I'm like, it's kind of, it's giving the same example, right? His goal was to get the Britishers out of his region, right? So if you do methodologically and says, hey, you know what? Either I can apply it across randomly, get the huge force, and then fight a war and then get it out. Versus if I go and just say, okay, I'm not going to worry about everything. I'm going to worry about this small portion, win that 45, then worry about the second small portion, win that 45. Then eventually I will get to that, the whole region. Right? That's the Agile mindset. Right? So same thing, it's historic, right? If you talk about, right? So if you look into the Chandragupta Maurya and Chanakya, right? It's all about not just the strategy, but it's executing those strategy into small pieces. That's what the Agile is. You still have a vision, right? The both needs to have a vision. But you can't just say, hey, because I have a vision, I need a huge task force to execute a vision. So that's what goes through the budget, right? Hey, I need this much money. It's going to take me $2 million to implement that vision. Therefore, I need this $2 million before I can start any of the work. You already lost a mindset there, right? The question is, how can I chunk that vision into small incremental value where I can deliver the value and start recovering the return on investment? So that's all I need, the first chunk. I don't need $2 million, whatever, $100,000 or whatever I needed to implement it. And then I'll get the flywheel. I get the investment and then do it. I may still need a little bit more incremental, but at any given point, I don't need it $1 million. right? That's the mindset.
So you're not suggesting waterfall at all, like following waterfall at all?
I'm not saying I'm suggesting one or the other.
Mhm.
I'm just telling you the pros and cons
Cons of-
for each one of them.
Cons more for
Right.
these.
So I have used all three methodology in my career. I have actually ran the projects that manages multi-million-dollar budget for each one of them. Right. All I'm just saying is that you have to adapt it, the continuous mindset.
So the world is getting transitioned from waterfall road to agile, is that what it is? Based
Yeah.
on the- Okay.
Right, so the agile is still a methodology. However, there's still a lot of cutting edge things that are happening, right? So things like you don't write a single piece of software till you finish writing the test for it. Right? The mindset comes in, I don't have code. What am I going to test it? No, you have the requirements. You're going to validate that the system fails it. Then you're going to build a system to prove it. Now it works. Right? That's called test-driven development. Right? There are a lot of engineering practices come in because, and part of it is the need to adapt to the market. That's what the bottom line is. As I mentioned, right? Facebook does it release every hour, right? You will just say, hey, wait a minute. I have millions of users using Facebook at the same time. How can you bring its system down to test it, right? No, it's a continuous deployment. You just phase it out. So you're using the old system, the next time you connect it, you're already gone to the new system. You don't even know, right? So there are a lot of engineering practice that happens, right? Some of them is very difficult to do it in an old mindset. That's why the Agile is becoming more popular because it essentially it's all about mindset and it levels plays the field versus a big company versus a small company. In fact, it gives a much more advantage to small companies because they don't have a legacy mindset to carry it and transition people to. Good with me so far?
Yeah.
Okay. Having said all of that, right? So what you're going to see is a lot of companies that you go into the marketplace is going to be started using Agile, right? Because they realize that the funds are not infinite. They need to better manage their money. And the way to better manage money is doing an incremental and learn it quickly. Or the common term that we use it is, if you have to fail it fast. Don't wait it for 3 years to fail it,
Right.
right? Give the same example to the kids nowadays, right? When they go say, hey, I'm not decided for 3 years in the college. That's fine. Do you understand the cost of it? Because at the end of the 3 years, you decide what major you want to do it. You're spending another 3 years. So instead of graduating in 4 years, you're graduating in 6 years, right? A, the time. 2, the cost. 3, you're not making any money till you graduated at the end of 6 years, right? So your return on investment is also going to be longer, right? So it's all about the mindset. Okay. So let's talk now, whatever we do it here, right? So think about it. The activity that irrespective of which of the phases you are, or which of the methodology you're using, still needs to be done. You still need to understand what your user wants. You may not need to know everything, but if they say, hey, I want to do it 1040 easy, let's understand what is required. What does it mean to be doing filing a 1040 easy? How do you know that what criteria you use it? What laws you need to use it? What computing tables you need to use? You still need to know that. And you will still need to know that even if you're using waterfall, because 1040 easy is one of the flavor, right? So whatever activities that we do it is still needs to be done. It's just that what is the scope and how often you do it's different based on methodology you use. So everything that we talk about, right? You're building an assistant with a business case. You still need to do that in a waterfall. In case of Agile increment, you need to say, hey, we are trying to do this sprint to do this particular subbeat of it. Well, what is the value? Why I'm doing it is, what is the return on investment? Versus if I'm doing the entire system, you still need to do it. small versus big scale. Planning and monitoring. You still need to plan whatever the activities or whatever the system you're building it, how long it's going to take it. If you're doing it sprint, you need to say what feature you're building in 2 weeks. In doing that, you still need to monitor. Am I doing that or am I failing? I need to understand the requirements. It's not only just business cases. Tell me the detail. What and how and who, all those details. I tend to organize it so that somebody who is building it understands how everything fits together. Okay. When a user speaks one term, a technology guy is going to speak another term, right? I need to make sure I can translate and then get them on the same page. Still needs to be done. I need to do requirement management and communication so everybody knows what is expected, or when it's expected, and how it's expected. Okay. And as I said, it's not good enough to just say it's putting together a requirement. You need to tell it how it's going to be validated or what is not need to be done in order to validate it. So you can just say it's, hey, build a 1040 easy application for it. Well, how do you know it is working as expected? What are the things you're going to check it or you need to validate in order to make sure it's working?
So validating requirements, wouldn't it be the same as eliciting requirements?
No, those are two different things.
Because the input and output needs to look the same, right? So,
Yes and no. Hang on to it till we get an example. So think about it. Eliciting requirement is, I need an electrical plug there. That's a requirement. Validating it is that plug is there and then electricity is flowing into it. One is telling it what it should be. The other one is proving it that it is what it is.
but the electricity needs to flow through the, plug or the cable. That might appear somewhere in the requirements as well, right? That is how it should work. Is
So when I just say, hey, this light needs to be controlled by this switch,
okay.
right?
Mhm.
So that's a requirement.
Mhm.
Right? How I'm going to validate is actually I'm going to check this thing. Is it controlling or not?
Mhm.
That's a validation,
Mhm.
right? Elicitation is what it should be. Validating, is it what it tells it to be? Those are two different things, right? It often seems it's the same thing, but it requires a little bit more execution, a little bit more validation, a little bit more proving it, right? So, so for example, right, let's say when I say it's 1040 easy, let's say I have a dependent, right? It just said, hey, you can identify a dependent. It's good, but what if there are other conditions? How do I make sure that those conditions are fulfilled? How am I going to test it? Well, I have to create that scenario. I have to add a dependent, right? And see it if one scenario that it says it should allow you allows me, the other one doesn't allow me. I have to validate, I have to run that, I have to simulate those conditions, right? So another example, right? It says, hey, you need to build a 4-bedroom house, right? That's my eliciting requirement. Validating is I'm actually going to each of the room and make sure they exist. That's a validation. Okay. So the question comes at is why do you even need to be more precise in terms of capturing and managing the requirements, right? So this is really old study. So it was done back in 1994, and it was done with over about 8,000 plus projects. Okay, and they looked into and says, hey, the projects fail. What are the main reason behind this 8,000 plus projects that failed? And they looked at it and categorized it, right? And the more important thing for you is there are other factors, like you said, lack of resources. Well, I don't have money. Well, I can't, that's why project has failed, because there's no money to continue with the funding, right? There's nothing much anybody who is building can work with that, right? It's the people who are planning and providing finance for that. But you may have a lack of planning. So people say, hey, I'm gonna build a 4-bedroom house. But if they don't have any planning, it's probably not gonna be as good as it needed to be, or it's gonna fail altogether. That's not gonna pass the county codes and all. But if you look at this wheel, right? There are a couple of places where I wanna think about. Incomplete requirement led to 13% of the project failure. Changing requirement led to 9% of the project failures. Okay. What that indicates to me is I didn't know what I was building it, or I didn't have a good understanding of what I need to build it. Things changed, right? Well, why it changed? Because I didn't do a good enough job in the first place to understand what needs to be done or what could be the factors that could impact my risk analysis aspect of it. So when you add those, it's about 25%. So 1 out of every 4 projects failed because of the lack of discipline around requirement. Significant, think about it, right? So if I can just add a good business analysis mindset and discipline, I can eliminate 25% of the failure right there. So there are a lot of other things, right? So lack of user involvement. Part of that is also, hey, as a business analyst, I need to know who all I need to talk, what are the users, make sure they engage, make sure they have provided the needed input to do that. There are other factors wherein you can influence as a business analyst to avoid the failure, but these two are directly contributors. That's the whole reason why this whole mindset and skill set exists. Okay. Here's the cost of forward analysis. So that one was a failure. This one is the project was still successful, but it cost way more. Right? Look at that. About 50% of the problems that was found in software, you can trace it to the requirement errors. Okay. 70 to 85% of project rework cost is because of the requirement errors. Okay. So $100 item cost you $220 because you didn't do a good job here. Look at that. Okay. Look at that. More than half the project cost overdone by almost 3 times. Okay. Look at that. 1 out of every 6 is only completed on time and budget. But it still didn't tell it that it was completed on time and on budget with the expected scope. Okay. 1/3, almost 1/3 of the project canceled before. That's where I was talking about waterfall, right? If you're using waterfall, 1/3 of your investment is kind of gone waste completely. No return at all. How many of you want to do that kind of investment?
Yeah.
Right? So now let's talk about, when you talk about software development, right? There are 5 broad categories where you're going to see it, most of your project is going to fall into. Okay. First one is the system doesn't exist. You're building a completely brand new system. Okay. So this is where you identify a need or a new market area where you need to optimize it. Okay. Another category is the system already exists, but needs to be evolved or enhanced to provide additional capabilities or adaptabilities. Okay. Third one is, yes, I had an old system, but it's too much expensive to maintain. It's brittle. I need to go ahead and rewrite it. For example, right? So if you may be doing it a 3-tier systems and it was running into a whole bunch of old technology. Over the period, you don't find the resources to maintain that technology, right? You don't find many COBOL developers nowadays to maintain the mainframe systems. The other issue would be is, as those systems are put on the internet, right, there are so many security holes. And nobody's patching into the old version, because obviously people are going to patch only on the newer version. It's not going to worry about investing in a really old version of Windows 3 or Windows 98 to fix things, right? So I need to rewrite it to make sure it's more secure, because now I have more liability involved with all of my customer data. So I may have to rewrite it. So sets of your project is going to focus on rewrite, where I want to replicate the exact same functionality, or I need to adapt some of the functionality, drop some, add new, but still rewrite the whole system. Then the next one is going to be a platform migration. Okay, so things running on a really old machines, you need to migrate it to the new machine because you can't find the parts of the old machine, or you can't find the support for operating systems. Then I need to migrate it into that. Okay. And one of the last one, which you will see many of them, is the data warehousing. I'm getting so much data. I need to manage my data properly. I need to put some intelligence on top of that data to make a sense of that data. Like, for example, with the fourth industrial revolution, right? We talk about IoT, right? Or internet connected devices. You need to make sure that there are so many data coming in, right? I have a temperature sensor coming in. I have a garage door opener sensor coming in. I have people trying to like hack into my Wi-Fi, versus I may have any other, like it's my fridge may be sending a message because it's all electronically connected now, right? I have to manage all those data. Well, how do you make sense of it, right? So you got to build and enhance those systems in terms of data warehousing. And it gets even more sense when you add the cybersecurity or people, like it's big companies and big banks needs to worry about continuously monitoring where the people are coming from it, what kind of data they're accessing, are they allowed to do that? If not, what are the violations? Who is looking at those violations? How they're addressing the violations? All of those audit requirements are required.
So if you build a new system, you would still need to migrate the data, right?
This new system is brand new. There's nothing legacy exists.
So you won't be, in those cases, they don't use the old.
Because I don't have any data, because there's no system exist.
Oh, yeah.
Right? In a rewrite, I
Yeah,
need to worry
data
about
migration.
potentially like data migrations,
Right.
right? So that's a component of it, but data warehousing is altogether different. But I have massive
Sorry,
amount
I
of
think
data
I
that I
meant-
need to do that.
If you rewrite,
Yeah, you will have data migration,
it
yes.
was.
But not only just data migration, right? You also have the user migration. Well, somebody was using this old interface. Now they need to go start using new interface.
Now, this really helps me to draw a clear picture of how exactly the IT invests money in the form of how does these project works. I mean, thank you for that understanding, but Billy, is there any way that, let's say there are like 5 types of projects, okay? The IT world is much more different. Is there any way like the company is involved in like 2 common scenarios? Let's say the company is trying to enhance, and at the same time, they're probably working on data warehousing, and that's where the dual scenarios comes into picture.
Yeah, so don't think these are at the project levels.
Okay.
These are not at the company levels.
Okay.
A company may have a whole bunch of projects,
Okay.
right?
Mhm.
So a company of the scales of Chase or Nationwide, or even if you talk about Facebook or Microsoft, they may have thousands of data warehousing projects going at the same time.
Oh, okay.
They may have hundreds of rewrites.
Okay.
They may have a huge bunch of new systems being built. It's based on a scale. Now, if you look into a small firm, we may not have a lot of people or a lot of assets and resources. They may have to prioritize, hey, we want to do 5 different things. But at this point, it makes only sense to invest in this 2. The other 3 can wait.
Yeah.
It's completely fine.
Sorry, and I'm just trying to compare my previous sessions. And testing implies everywhere.
Yeah, testing is completely different.
It's
Right?
different.
This is the project.
This- yeah,
I'm
yeah.
building the new systems or
Right.
dealing with the system. I still have to do the business analysis in each one of them.
Mhm.
I still have to write the code.
Oh,
I
right,
still have to test it.
right,
I still have to go through user acceptance.
sure,
I still have to do the automation in some cases.
sure, sure.
Right?
Yeah.
So, now, think of this, right? This is true in general for not just the software development, for any business problem or any problem that you run into. You need to have a mindset to analyze the problem, right? So typically, in order to do the analysis around any problem, there are 4 key factors that you need to think about it, right? The first one is you first need to understand what is the problem, right? So let's say if you're suffering from an illness and you go to the doctor, what is the first thing doctor does? Ask you a whole bunch of questions to understand.
Sure.
Where is your problem located? Is it your hand? Is it your leg? Is it your tummy? Where is the problem?
Right.
Right? So they're trying to understand that. Then the objective, and they said, okay, you understand it, so your leg is hurting. Tell me, what are you expecting to resolve here? You want the pain to go away temporarily? You want it to resolve the issue permanently? What do you need to do? So what is the goal that you're trying to do? Driver, right? Well, why do you want it to be fixed? Well, because I'm a runner, and when I run it, it hurts. I can't take part in any of the competitions. Well, your driver is the competition, right? Your goal, your objective is that, hey, I'm trying to get it better so that I can run better, right? The problem is my leg is hurting, and when I run it, it's just so much pain. My ligament is, right? And the scope. Well, what is the scope? Do you want to completely resolve it? Or do you want it to painkiller so that you can run in tomorrow's race this one?
Sure.
What is your goal? What is your scope? If your scope says, hey, I want it permanently fixed, so I don't have to deal with that every time I have a race, I don't have to take a painkiller. Well, that's your scope then. You need a surgery. Or if I'm just trying to get by tomorrow's race, well, let's just take the painkiller. And then if it recurs, let's revisit later. So my scope is significantly different. Right? Same thing with the software development. Well, what system you're trying to build it? Why do you want to build it? What is the key driver behind it? Well, what is the scope? How much big you want to build it? Do you want to do this? You want to automate everything? You want to automate this part, but do it this much manual? What exactly you want to do? That's the analysis that you need to do. Okay. So this will sound familiar to you, right? So when you look into the business problem, so there are all the business problems you can categorize into one of the 5 types of problems. Okay. These are the 5 types. Okay. So let me give you an example. Okay. If I'm a small mom and pop bookstore, okay, I have 3 bookstore location and 1 warehouse. Right? So if that's the business, I have it. Okay. And I'm trying to optimize things. Right. So I may have a need to find a book, in which location it exists, and how many copies. Right. I have to do through a search process. Right. And if I'm searching it such a way that all of my books are not organized properly, I have to go through every book, right, in order to figure it out whether I have a copy or not. Okay, so that's my search process. I have to go through everything. Now, if I say hey, what if I have organized books by author's name? Now it's probably easier for me to search rather than going through every book. I have to just figure it out where that author's section is located and then just have to go through only that section and nothing else, right? So instantly, just by reorganizing the way I'm kind of storing the books, I gain the process improvement. Right? The searching process is speed up. Second scenario is the same search was done manually by people or my employee at that, right? My focus is if it was randomly placed and they have to go through every book, it's going to take them much more time to look through it, right? That means if I tell my employee to search for 2 books, it may take them 5 hours to go through the entire set and then another 5 hours to go for the second book, entire set, right? But if I tell that person that, hey, everything is organized, then it may not take them 5 hours, right? They have to just go look through that authors section and look through 50 books that they have, which may take, let's say, only an hour. So now from 5 hour productive, so the person was productive to do one search every 5 hours, he's more productive because he can do one search every hour, right? So all of a sudden, I increase that employee's productivity. Okay, so that's, if I'm trying to find a means where I can make my employee more productive, then it's a productivity improvement. The third one is cycle time improvement. So if I'm looking at it, hey, how long it takes me to go through all the locations in a warehouse to find a book. Right? I may start with it, let's just do a sequentially. Then the first one takes an hour, second one takes an hour, third one takes 1 hour, in a warehouse takes another hour. Right? So it takes me 4 hours to go through an entire set that I have it under my inventory to find how many books I have. Versus I can just say, hey, you know what? Let me make a phone call so all 4 can start it together. Then instead of doing it 4 hour turnaround, now I can potentially get it in 1 hour, right? So my cycle time to get my work done is 1 hour. So that's a cycle time improvement. So if I'm doing something that reduces the amount of time it takes it from start to end, then that's a cycle time. The next one is need to reduce cost. So if it's taking me 2 employees to do the search at every store, and it's taking them 5 hours, so I will put it as how much it's going to cost them. Let's say it's a $10 an hour employee, and they're doing the 5 hours to do it, and now I have to employ 2 employees to do it. So that's $100 cost per location, right? So it's going to cost me $400 to perform a search. And I say, hey, what if I can, my goal is not to spend $400. My goal is only to spend $5 to do the search. Well, that's a need to reduce the cost. I cannot afford to do that. I have to do this. But now in order to do that, I have to employ a whole bunch of other things, right? I may have to catalog the books. I may have to put an inventory into the computer. And then my incremental search is going to be a lot more faster and cheaper. Okay. The last one is if I need to improve the market share. So the example that we talked about, right? Doing it a tax return, but starting with only easy. When I'm providing only 1040 easy tax return, my market share is probably only 2% of the people file that. When I start moving into 1040 standardized, which is another 20% of the people file it. So now I'm making my market share potentially from 2% to 22%, right? Because it's 2 plus 20. So that's the increase in market share. So now I'm more reaching out to more customers for my products. That's allowing me to increase the market share. Right? So most of the business problem that you're going to look into it, it's going to fall into one of those categories. So what I want to do it is this one. You guys read through it?
Yeah.
Okay, let me see if I can. what I want you to do it, and let me write it down here. Okay. So I'm going to put the categories, right? Process improvement. And then next one is productivity improvement. Cost reduction. Cycle time.
So we have to determine whether this process, productivity, cost, cycle time, right?
Yes.
Oh.
Okay. So these are the 5 categories of the problem that we said that it's going to fall into.
Oh.
What I want you to do is look at this thing, read through. Yeah, good. It fits in. So read through this thing. Now, there may be more than one drivers, but there's only one primary driver.
Sure.
So I want you to read this and says, hey, if I have to answer this question or this proposal to build a system, which one of the category is the primary driver for building that system? Okay? So take a 5 minutes or 10 minutes to read it. It's 12:05, so read it till 12:15. Read through it. Okay? And then figure it out. What do you think it's going to be? And then we'll start having a conversation.
Sure.
Okay?
Can I go ahead and answer?
Did everybody finish reading it?
I'm finished, yeah, I mean, yeah, I'm
Let
done.
me check it online.
Mine, yeah.
Okay, did you finish reading it online? Or you have questions? Choose quiet one. All right. So any questions before we get into the discussions? All right.
So, can I ask a question?
Uh-huh.
What is the difference between the cycle time improvement and the need for the process improvement? Is it overlapping each other?
No, cycle time is, if you think about it, is overall end-to-end. I want to reduce the time it takes it. Process improvement could be is, hey, I want to do it a better way to do the things. It may still result into the same cycle time. But instead of doing all the manual labor, now I'm doing it electronically. Instead of doing it sequentially, I may do it parallelly.
So is it a piece of the need of?
So this may
process?
drive this, or this may drive this. But the goal is, what is the primary goal? Or do you want to reduce the cycle time?
Like
or
the
do you
whole
want to do a
process?
process
You mean to say
improvement?
the whole process? Cycle time means like from beginning to the end?
Cycle time is beginning to end. So for example, let's say, if you say, hey, I want my customers, like let's take an example of Amazon, right? So they had, hey, I can give you second day shipping, right, with the Prime. They've started that, hey, there are certain items we can do it in 2 hours. Right? That's a cycle time. It used to take 2 days, but now it takes it only 2 hours. Now, I can still do the same thing by putting more people and reducing the cycle time. That's one way to do it, right? I didn't make any changes to process. I just added more people to do the exact same thing so that they can fulfill faster. Or I can do, hey, I need to do the cycle time improvement, but I can do that if I change this, and this process set steps. Then it will allow me to reduce it. That's a possible.
So when it says need for process improvement, it has to be like going
Better
all
way to do
together
the
with
thing.
the new procedures and
Right.
everything from
Yeah.
all the bells and whistles.
Right. Let's say if I went to go for a surgery, right? And they say, hey, it is going to take me 20 minutes or like it's an hour in the pre-op before they prepare for the surgery, right? That's a process, 1 hour, right? But they say even after using that process, we are like it's not seeing it certain reduction in time in the post-operative conditions. So they said, what if I change the process? It's still going to take an hour, but I check this thing first before doing any other activity. That's possible, right? So now I improve the process, but at the same time,
Thank you.
my cycle time still remains the same. It still takes 1 hour to do the pre-op activity.
Okay.
So that could be possible. Okay.
Yep.
So what do you guys think? What is the problem? What is the primary driver that they're trying to resolve?
It's the time.
Is it process improvement? Let's go through it. How many of you think it's a process improvement? You think it's a process improvement is a
Because
primary
there's a
driver?
lot of things which is involved in it.
So-
There's not one single issue about the timing.
Okay.
It's also about the new products they're adding. It's about the new market they're entering. So there's a lot of components within it.
Right, so they're trying to like it's do a whole bunch of process
Yes.
improvement. That's the primary driver for your mind.
And that's what I think.
Okay, that's good. That's all right. Productivity improvement. How many of you think it's a productivity improvement? Okay. How many of you think it's a cost reduction? All right. Who thinks it's a primary cycle time improvement? Both of you think it's a cycle time improvement primarily?
So based on my understanding, it's something like businesses well defined, they have pretty much good hold on the market. They have like 4 locations. So it's the only thing that what they're trying to do is business wanted to get everything done in 2 weeks.
Okay.
Also, plus, they
Oh.
also mentioned like they're actually trying to order checks manually, and
Mhm.
they would like to manage everything, just to make sure that the things are delivered on
Okay.
timely basis.
All right. Anybody thinks it's a primary driver's market share?
It could be because it does mention they're looking to.
Which one is
next-
primary? There's only one
We
primary.
Oh, no,
I'm talking
primary
about
is
primary, yeah.
cycle time.
Primary cycle time,
Yeah.
okay. I think it's online.
The next is the group
Adranti,
price.
do you know, what is your opinion? Which one of the 5 things it is primary driver? Can unmute yourself.
Okay. Hello.
Which is the primary driver, in your opinion?
Okay, from here, let's see.
From this 5, is
Uh-huh.
new process improvement, productivity improvement, cycle time improvement, cost reduction, or market share gain?
Okay, currently all I'm seeing is just the slide. I mean the
No, but so this is the problem. Are you able to see this problem area, which I highlighted?
oh, okay, yes.
Right, so this problem area, what do you think is the category? What category they're trying to address it here as a primary driver?
The primary driver.
Yeah.
Um.
And out of the 5 that we talked about, right? So
Mhm.
talked about this 5 things, right? Need for process improvement, productivity improvement, cycle time improvement, cost reduction, or market share improvement. Which one of the 5?
Is the process improvement?
So yeah, you think it's a process improvement?
I think so because they want to show all their products, and they also want to make entire order to ship process online. I'm thinking is that, yeah, product improvement.
Okay. All right. So Kashmira, you also mentioned for process improvement, right?
Yeah.
What are the things in this problem statement that made you think that there is a process improvement? Talk to me. Think
Because-
about love.
Yeah, because there are multiple issues right now which they are facing, they want to improve on. It's not just one singular which can be resolved by.
So name a process for
So
me.
they want to float it online, which is like you need a different procedure to go about with it.
So
Altogether, if they are not online.
mhm.
Secondly, they need to upload more images, or introduce more products to the market, showing that the products have to offer.
Okay. So you're talking
Also,
about this.
yeah,
This.
the
Okay.
online thing. Also, that they have a new clientele, I guess, the new market, which they are trying to kind of capture. So they're kind of introducing the product to the new. So there will be a different kind of procedure altogether when there are so many components
Okay.
involved in it. I think that's what I thought.
Okay. That's
Because
good.
the whole criteria about the quality, the customer loyalty and the promotions with the different pricing component is different also, which is not going to be, it's going to be a different process altogether.
So think of it this way, right? If you think about it, it's going to be different process. Does that process exist?
There is an existing process.
Okay, so you think if there is a process exists, you modify that process to deal with the other one. Okay, because if the process doesn't exist, then there is no process improvement, right? So I want to make sure that there is that distinction. Now, 2 of you mentioned cycle time improvement. Tell me what words in here made you to believe that it's a cycle time improvement and not like what she mentioned as a process improvement.
So 2 things that would mainly focus on the cycle time is, the one that says they would like to, depending on the product, they take between 1 week to 3 weeks to complete the order.
Okay, so this one, right?
Yeah, this
Okay.
is the highlighted one, yeah. And based on the information given in a paragraph, they have a strong hold, they have employees, they have everything. I mean, they're established people, but they're only focused on one thing, based on my understanding, is to deliver the product on a very less time span.
Okay,
I
so
mean,
we're
I
talking
do agree
about
with her, but
same day service to some of that.
yeah, absolutely. And of course, there are last two lines also, which also gives a little bit weightage to that point.
This one?
Yeah.
Okay.
Yeah, yeah, the last bullet. Yeah.
Okay. What do you think, Rafi?
Yeah, he absolutely covered what I wanted to say. So they are already an established business. They are looking to better growth in the next 10 years. So the first thing that struck was that they want to increase the delivery time. I mean, they want to improve the cycle time basically. And um, what I felt was, what I saw there was that they're already, they have a third party vendor as well in place. So it's like they already have a process, towards the change or towards increasing this,
Volumes.
decreasing the cycle time. Basically.
Okay.
Yeah. So
All right.
It's a tie-breaking event, believe.
So what we used
So
to
hang
call
on,
like a
but I'm not
turnaround.
done. You know, I'm not done asking questions.
So basically, the reducing the turnaround time
Okay.
of something. Yeah. So when they are putting more people in it, like a third party vendor who will increase, the quality or the delivery.
Okay. All right. So let's talk about, right? So let's get that, right? So there's no productivity improvement, right? Because it doesn't talk about anybody saying, hey, you're doing this much, now you do this much in the same time, right? So everybody good with that?
Yeah.
Okay. So cost reduction. You see anything that at all talks about cost reduction?
No.
No? Okay. So I know we talked about process improvement, cycle time improvement. What about market share? Do you see anything at all about the market share?
Yeah, they do mention about like they're actually trying to participate with the corporations. But
Okay.
that means that they have actually good demand overall in the market. I mean, that's, and also
Okay.
this helps me to understand that because it also mentions they have a robust growth in past 4 years. So, I mean, if you like specifically concentrate on the first primary aspect, cycle time comes first into mind. I think the on
We should disconnect this Bluetooth.
If you can ignore it, I think it's a Google voice.
I want to like it's getting rid of the speaker.
Yes, I'm logged into my Google Voice account on the computer, so that's the reason.
Oh.
It's coming over there.
I thought the system liked my views.
All right.
Yeah, it rings all the places, I guess, on my phone as well as.
All right. So coming back to your question, right? So you said that like there is already market exists, right? So they are not going to try to increase any market share.
I mean, primarily, I'm not, no,
Okay.
not the market.
All right. So what do you think the keywords are in this whole paragraph?
I just was about to say that there's a keyword. Oh gosh, where did I lose it? So I believe that I'm not taking this as a debate competition or something, but in a way that when I thought about, because I asked you about the cycle time improvement, and then because I was kind of a little bit confused between those two. But when I think about cycle time improvement, all the checkpoints are not checked. That's what I feel. I mean, when it says that it needs to offer customization, it needs to cater the new clients they are having in the database. It needs to change the price, the quality, the customer loyalty, the promotions with the different pricing and everything. That was not fitting. That was not getting in the cycle time improvement functionality. And that's why I was leaning more towards the need for the process improvement, because it has everything which is ticking the box out for all the requirements mentioned out there. I may be wrong, but
No, that's okay. So as you said,
No
right?
one knows at this point.
So hang on, so you said this is not a
When they're
debate.
bonuses.
I
Oh
don't
my God.
So hang on,
We-
this is not a debate, but
Yeah.
in real life, that is gonna be a conversation,
Oh,
Yeah.
right?
Yes, there will be a
So
debate.
now that she put it her side,
Mm.
what do you have to counter it to say it, that why she is not right, why you guys are right?
To be honestly speaking, it focuses on only one thing on this paragraph, which is they need to reduce the time.
So you think time reduction is the key word on this?
Time reduction is the key word.
Okay, what do you think?
I mean, it is
Yeah, after
established.
she mentioned that, it does make me think, but again, what prominent I see there is they want to deliver faster than they used to before. But
All right, so let me counter
Oh my
some
God,
of the
okay,
things.
okay, I need to
Let me
think about it.
counter some of the things now. Okay? What do you think the purpose of the first paragraph is?
to show where they stand,
To show that that's fine. Good. What is the purpose of the second paragraph?
What is a need they would like to make?
Hang on.
Yeah.
So what do you say?
What is a need? I mean, what they want to do.
What is the need?
Yeah,
Okay.
I feel it's more what is going to be more forward, like down the line, not the immediate.
Right,
goal.
okay. So what are they asking? If I read this problem statement, what are they asking
to
to do?
customize employee kits.
No, what are they asking me to do it?
Okay, understood.
I'm a software developer
Yeah,
that is working with them. What are they asking me to do it?
all the bulleted items.
What is the purpose of bulleted items? What are they asking
To
me?
improve the process.
Are they asking me to improve the process?
I'm stuck on that right
To
now.
improve the cycle time.
All right, so you're saying improve the cycle time.
I hope
What
you
are you
know
saying
that.
online?
Our work doesn't change.
That's okay.
Yeah. But I know, I mean, you.
For the record,
trying to
you
make it
guys
more-
missed the keywords altogether.
Oh
Oh,
my God.
we are all on the wrong.
Actually, I was looking at something and I was like, oh, this is something which.
Are we all on the wrong track?
Maybe.
Which paragraph is more key, the first or second?
The second,
Okay, what does second paragraph calls you to?
just because, they just want to, I mean,
Picking orders.
it's an opportunity for them, like, to do something new. and-
Support this.
Okay.
Plan management.
So the first thing you guys need to do is when this is the key for the business analyst, right?
Oh my God, okay.
Remember what did I show you in the previous slide?
Yeah.
Understand the problem.
What is the problem?
What is the key issue?
So remember the fourth step. Understand? Understand what is the objectives, what is the drivers, and what is the scope. If you understand those four, then you will be able to tell which one it falls into.
Yeah.
There's a reason why I shared this slide first
Sure.
before sharing the problem. What is the problem? And what is the scope? They're telling me to build a system, right? What is the scope?
They would like a better way to manage their overall order and fulfillment process.
This is where they're saying that they're gonna invest.
Yeah, I mean,
Why are they investing it?
to customize, yeah.
What was my market before? Individual customers.
Right,
I see an opportunity to grow my market share, to go into the commercial world.
yeah. Okay.
I'm growing my market share to go into the commercial world. Because I don't have any of those
We
customers.
were all
right?
way
Yeah, I
off.
said that point, but it was, okay.
Okay,
Mhm.
and what is my scope? There's 5 capabilities. Now, why did they say there's 5 capabilities? because they tell me what is my current business state, where is potentially they're lacking, and why they want to build it. But if they were not going to do it, probably they will take a different path and not tell you to build it. But they see an opportunity as they grow into the market share to fix some of the pains that they have. But they're not going to fix it if they were not going to go to the market share.
So market share gain is not.
Market share gain is the key. Because I'm going to, today I have 4 physical locations. Look at that, what they say. I cannot take any orders from online. All I can tell you is what my products are. But with getting into employee, I need to take orders online. So I'm no longer limited to 4 physical locations there. I can take it anywhere online, right? But when I go with the online, I have certain business goals in order to fulfill that online capability. I want to do that, but I also want to make more money and says, hey, you know what? You want it tomorrow for birthday? Sure, we can do that. You want tomorrow for a company kickoff events? We can do that. Just pay more money and we'll do that.
The keyword is taking orders from corporations.
Precisely, right? For upcoming, they decided to start taking orders. So that tells me they never took it before, but now they're going to go into that market. That means they're expanding their market share. And that decision is what is driving everything else. It's not the other way around. You guys with me?
Yep.
Right?
The first driving force is to enter the corporation scene, and then the other driving
Precisely.
forces.
Everything else is a side effect, right?
Right.
This is the main reason why I'm doing it. It may help me with the cycle time reduction, right? It may help me with my process improvement because I order and fulfillment process. But the key reason I'm doing everything is because I want the market share. And once I go online for this commercial, I can potentially expand that to individual customers also, because now I'm no longer limited to 4 things.
Was so tricky.
Does it make sense?
Of
Yeah.
course, it was tricky.
It was fun.
Yeah.
I have been.
He got it.
I have been-
Echo.
No, not echo. I have been through that phase earlier, so it's really tricky now.
No, it's,
I-
it changes
it's
the
fun.
way you think.
Yeah, yeah, sure.
No, I
Once you
liked
go
it.
through with that
Yeah,
procedure
yeah, of
once,
course,
it
of
really helps you to think in a different way and a different direction.
Sure, sure, yes.
So the key thing, and this is something that I want all the business now is to think about it.
Yeah.
It's the same text that all 5 of us read. Right? It's exact same English. There's nothing was changed, right?
No, no.
Your interpretation was different. Your interpretation was different. My interpretation was different. So the key thing is to look through it, apply those principles that we talked about.
Yeah.
The reason why you need to apply it is if you would have went it as they're saying that, hey, it's a process improvement or cycle time, the every question that you ask that business would be centered around those.
Yeah, that's what I was thinking that. But then when we go with the market share gain option, does it fulfill all the requirements? It doesn't, right?
So hang on, right? So remember what they're asking. In order to support this plan, they're doing it. They're not saying do all these things for my current customers.
Okay.
So if you focus on your current customers, you're going to miss the whole boat. Because remember, they don't have any online ordering today. So customer don't have to worry about uploading the image. Give me the flash drive. I'll do that and I'll use that image to that. Because you have no ability to upload it. Right? Or I may be asking, okay, why don't you email it to me? The image that you needed. Right? And the price, I don't have to worry about price because I will tell you exactly what it's going to cost based on what you're telling me there. Right? And I know exactly whether I have item or not. I can tell you, yeah, I can get it all done today or not. But when you're online, you don't have that ability. That's why you need all these features and capabilities. Now, eventually I may just say, hey, once everything is working, I'll change my current business to take the benefits of these things. But for now, I'm going to continue my business with the customers as is. Because it's going to take you some time to build it, right? I'm not going to stop my business while you're building it. So while doing this, I'm not telling you to improve any one of these things.
So you mean to say, okay, in order to have a process improvement, there has to be already a process in place. And in this
Precisely.
situation, there was no online option
there is no
available for
process.
anybody.
So I'm not improving anything of this thing.
Got it.
There is a process, but it's not online. It's when somebody walks in through the door to one of my 4 locations.
That makes more
These
sense
points will come into play only when there is a collaboration with the corporations.
Precisely. This is initially targeted only for these groups. Make sense?
Yeah.
Right. So the key thing is business analyst is to look through it and having a conversation, right? If you're like it's in a bigger group, or even if you're individual, you need to have that conversation with the customer, right? Here, ask them, hey, tell me what exactly is your primary goal? If you have to solve one thing, what is the one thing that you're looking for? And he will tell you, one thing I'm interested is to get this thing in place. That's my first most priority, because that's what it is. I gave you all this information so that you understand where we stand today. You understand what we have it in place and what we don't have it. So that when you start asking questions, you do it. I gave you that because I gave you the vendor information that I do some behind the workshop itself because I have a printing or 3D press or 3D printer. But there are certain things that I may have to send it to the external vendor to customize it, forward it, and then ship it. Right? That means when you're building this things, right? When you just say is that all the products that they have it, if my end customer is saying that, hey, I don't have those mugs that you're talking about for customization in the stock, I want you to take it off or just say it's not available. But I'm not going to make individual call. I want to have the ability to set the vendor in some way the process to so that it's makes it, hey, out of stock or in stock type of thing. That's why I provided all this information. I also provided you this information about the cycle time and where I'm heading to it so that you know that, hey, if I need to offer this premium service, there needs to have some conversation. You will ask me a question of, tell me the categories, what is going to come under premium price and what is going to come under, right? So there is some further discussion in terms of exploring what is my requirement in that space versus that. So as I said, this is just telling you what is my current state. This is telling you why I want to engage you and what is my primary reason behind it. Okay. So most often what you're going to start at as a business analyst is with just one page of concept, or if you're like it's working for a consulting firm, then the customers will be giving, here's a proposal, what we are looking for. You need to go further into the detail, read through it and figure it out where you need to start focusing and what is their main problem. That's the first step in any project work that you're going to end up doing. Okay. Make sense?
Yes.
Right.
Another brain teaser.
Now, I was just going to go ahead and okay. I know this is probably not very legible, but I think you have a handout which talks about all of it. What I want you to do it is, remember we talked about SDLC, the first phase is the planning phase. Right. So I wanted to give you, I don't think initially you will get involved in any of this decision making, but I want you to give you an insight of how the decision making happens, right? So anytime, any business, doesn't matter whether it's a small company or a big company, when there's some process that they go through it to make a decision, is it ready? Am I going to build a system, or am I going to invest the money in building the system or not? Right? So typically they go through a process where you first define what is my problem I'm trying to solve, right? So they give you a kind of high level estimate of what is the issue that you're trying to solve with, high level scope. Then they try to figure it out, what it's going to cost you to do that. Right, so you start with a problem definition, then you look into how much it's going to take me in terms of money to implement this thing. Then they also do something known as a time estimate. Well, how long it's going to take me to implement this solution. Right? It doesn't matter whether it's an agile way, waterfall, whatever the way you do it, how much time it's going to take me to finish it. Then once it's finished, what is my return on investment is going to look like? Okay, so they ask you to get these 3 factors in. Okay, so for example, if you say, hey, it's going to cost you $1 million, it's going to take 2 years to implement it, right? And then once the project is finished, it's going to add incrementally revenue of $100,000 every year. Now, if you think about it, what is my return on investment at that point? It's going to probably take me at least 10 plus years to get that. Because remember, that $1 million, if I would have invested somewhere else, I would have got return on it. So I had to worry about that return also over the 10 years. So it's probably going to be realistically 13 or 14 years before I can make the money. Businesses are not interested. Who knows? What if the product may not last in the market that much time? What if the market changes? I'm investing it so much money for what purpose? Or it says, hey, it's going to cost you $100,000. You'll be done in 3 months in implementing it. And once it's done, you will get $30,000 a month return. Now that makes sense because I'll make up all of my money in less than a year. So it makes a sense for me to invest it, right? So you collect that kind of information. And then once you collect that information, typically you go to a investment board, right? So if you're an individual small company, then you go with whoever your venture capital fund is. If you're in a big company, there is always a business and IT executives that essentially sit on the board to make a decision. Is it worth making investment in this proposal versus that? And they evaluate, they have criteria which say that, hey, certain companies have X years of rule. It says if any investment is going to take more than X years to get a return, they said we are not even going to consider. When it's going to be considered, they're going to just say, it's okay, how much this is going to return versus the other project. Because remember, just like you do all home budgeting, right? You have X amount of dollars only, and you figure it out where it makes more sense to invest it or get it. They do the same thing. And once they make that decision, it could be one of the 2 things, right? Either they say, yeah, it makes sense. Let's go invest it because it's a good proposal. Or they said, no, it doesn't make sense. It doesn't meet criteria, reject it. Or they can say, then the proposal is interesting, but not in the scope that you're talking about. Why don't you change this, and then come back with what's going to cost it, or how much it's going to return it, and how long it's going to take it. So they may ask you to redo some of the work, and then you come back through the proposal and review it.
But isn't that a manager's job, or is it inclusive as a BA analyst job?
No, that's what I'm saying. So that most likely you guys won't do it, right? Now, some of us, like it's not just the manager, right? So it's more an investment and architectural group that get involved in. Now, you may get involved in this process to figure it out, the time, effort, and cost estimate.
In the
Right.
business case.
And we have to build a business case, right?
So is it pricing and is a part of the analytical process?
Part of the analytical process is not pricing, but it's more about, hey, how much external software we need to buy. So as a business analyst, you identify what will be built internally versus what we'll be getting from off the shelf. If we need a licenses, how much it's going to cost it,
Okay.
right? And then do you have an alternate things that you can use it, right? So as a business analyst, you're trying to figure it out, what makes sense for this product, and then how much it's going to cost. Now, you're not going to go alone. You will have different type of people, right? You say, hey, it's gonna require me to run on 10 servers. Well, how much each server cost to purchase it and maintain it annually? You will have a group which will tell, hey, it's gonna cost you this much dollar to buy a new server and this much to maintain a new server.
So where does this process fall? Is it after
It's in the planning.
requirements?
No, it's in the planning. It's way before. Remember we said SDLC, the first phase is planning. This is helping you to make a decision. Is it worth even to go with this project or not?
So if it's an internal implementation or a kind of.
Yeah, or you can
improvement
just say,
process.
hey, can I buy off the shelf? It doesn't have to be internal implementation. Is it, do I have a business case that makes a sense to build this system or to buy this system? That's what it is all about.
So
Right.
usually the steering committee,
Yeah.
the company has a steering committee, right? Where they have CIO might be participating along with the business.
Yeah.
Basically, high-level manager.
So initially, somebody comes up with this idea of having this new improvement or this thing. Then they go to the
They
committee
all
or
proposals
whoever.
go to those guys,
Yeah.
but they have to justify.
Once
hey,
it's approved and all, then it comes
Once it's
to the
approved,
requirement level.
then it goes to requirement saying, hey, now we give a go ahead to work on this project. Let's do it. Think about it.
But business analysts may be involved in this procedure because of the
Right.
information.
Because all the data that you have to collect, right, the business case, you have to build a business case, right? Like for example, the house one that we talked about, right? If I want to build a new house, right, you have to build a business case. Why I want to build a house, right? Do I have a money, right? How much it's going to cost, how long it's going to take, right? And what is the return on investment, right? Hey, why I'm going into buying a new house? Maybe the old house is leaking, I have so much maintenance cost. Or maybe I'm staying in a rental apartment and I'm throwing away that money and not building any equity, that I might want to go it, or I may want to do a lifestyle change. You have to still put together all of those things to determine, does it make sense to buy a house now or build a house or not, right? You might be doing that analysis and you say, hey, you know what? It's not worth it. I'm better off staying in the rental place, right? Same mindset. You still have to do the business case. Hey, I want to build a system to automate all these things. Is it going to cost me that much? And it's not going to be in return. I might as well continue with the manual process, right? Because I don't have to do all those investment. I don't have to do the maintenance of the systems. I can just hire one more person to do the more manual work. That may be the reason, right? But you have to do those business case to say, does it make sense? And that steering committee makes a decision. Yeah, it makes sense. And yes, I can allocate that much money to invest. Because in order to build the systems, you have to borrow money from somewhere, right? Or use some money to build it. So that's what it's all about. Am I going to invest it or not? And then you play a supporting role in this thing, right? To
So-
build the case.
Kind of like a company, so at AEP, you play as a partner role with the business. You come up with actually business case as a business analyst. But like companies like Nationwide, they have other folks, business, kind of like analysts, but they actually work with the business. They are in the business side of things. And they actually come up with a business case, then hand it over to IT and work through that. So it depends on the company. But you most likely you'll be working with the business, writing the business case as well as involved in the proposal process.
Now again, right? It depends also. You may have a big organization, right? Where it's a big team of business analysts. And then at the entry level, you may not get engaged into that.
Lead
That somebody might be taking a lead and you might just kind of review and get an understanding that process, right? Or you still have to review the business case even after it gets approved. When you start doing an analysis, you have to read at what was proposed in the business case to identify the scope and get into what information I need to get in more in terms of analyzing. Right? Just like a one pager I showed you, that could be a part of the business case and say, this is what we're going to do. Of course, there will be financial data with it so that they can make a determination whether it's worth to do this investment or not.
Yeah, I think it's kind of like homework they have.
Yeah.
It's kind of like a links.
Yeah.
That will help you guys understand business case.
Yeah.
Website, so.
We have a home.
You will always have homework. Yes.
So Harshal and I are kind of old school. So I strongly believe that the time that you spend in classroom, you're gonna end up some portion of that time also at home in order to reinforce it.
Right.
Because me talking it here, it's not gonna prepare you to go out in the world and do the real work. You have to do some of the work.
Sure.
So that we can talk through it and says, yeah, it makes sense or not. Just like what we did that teaser problem, right? Does it make sense? Do you understand what it is, why it is that way, right? So that you can develop your questioning ability, develop your analytical ability. So, Herschel, did they have in the folder, in the email?
I gave them in the folder and because I
Okay.
had the wrong one.
All right.
It's
So-
already in the back.
So what do you have it, after the first tab, you have something called PHM system. So if you just now go into the, right after this. That's a custom creation. If you go to the next page. Yeah, that's it.
Exercise.
Yeah, the nursing software, right? So your homework,
Dilip, you wanna pull up for online, because you know, they have a copy.
yeah, hang on.
Page number
Flip to the next tab. So you see the white tab, right? Just
36 यहाँ पे नीचे लिखा हुआ है.
No,
अच्छा,
These are
page.
pages.
flip the tab, flip the first tab. Okay, and then take out, the first page is the description that we just saw it.
Oh.
Go to the next page. That's what this is about,
Okay.
okay? So this is a joint nursing computer software project. So your homework is to read through this thing and start understanding what it means, okay? I want you to explain the purpose of that proposal. So tell me, what is it talking about? What is the purpose of that proposal? Okay, so it's a proposal to build a software. Okay, so you have to understand, just like what we did through that one exercise, you have to read through it and then figure it out, which one of its problems trying to do it. What type of system development they're trying to do it. Remember 5 categories I said? New, enhancements, rewrite,
Sure.
right? Replatform. And what was the 5th one?
Data
Data warehouse,
Yeah.
right? So which type of system it is, right? So read through that and then answer these 2 questions. This and one of the other 5 types.
And one thing I would strongly recommend is if you don't understand the terminologies, okay, because this one is a healthcare related project, go and Google it. Okay, there is no harm learning the terminology about what they are talking about in the software. It's a medical related software, so.
Sure.
Yeah.
Okay,
So
I'm sorry, what points you said we need to refer to answer these questions?
So go to,
Data warehouse.
so go to slide number,
No, there is a slide for types of project, so you have to categorize.
I'll tell you the slide.
Very
So go to slide 33, not page number 33, slide number 33. So
Yeah.
this one, okay? So I want you to tell which one of these 5. And
I have a question, please.
Yes,
Will you be sending those information to our email, the homework?
yes, Herschel will be sending you to the,
Fantastic, thank you.
he will be sending you both the slides as well as the document that I was sharing it here.
Oh, okay, sounds good, thank you.
Okay, and then so you need to give the answer for page 33 and 35.
Okay, page 33 and 35,
Yeah.
okay.
And which one of the choice from 33 and which one of the choice from 35? Okay, and the way we can work is every Thursday, Herschel, have you already sent out the Zoom information?
yeah.
Okay, so every Thursday, we'll get together online over the Zoom. And the way we do it is Thursdays are typically time that we go for question answer, or if you've done any homework, just kind of review and discussion around it, right? So we will not try to teach any new topics on Thursday. It'll be more on, let's just make sure whatever our understanding it is, what the homework is, what we're supposed to do it. Am I doing this? Should I do this or that type of thing?
So this will revise or review on Thursday.
Right. So what that means is you need to read that before Thursday. Be ready with the answers. And when we'll do the discussion on Thursday over the Zoom, if any questions you have, as Herschel said, review it through the Google, Tom it, Like it's Google the terms to see if you understand. And it is okay if you don't understand. But then jot down those questions that what do you want to do it? Either you can send us through email beforehand, or we can talk it during that call on Thursday.
It's at 4 p.m., right?
No,
6:30.
It's a 6:30.
6:30.
Sorry, I had the timing wrong. It's a 6:30.
Yeah, there was
Yeah.
different timing and different, the
So-
link at 4 p.m., but the
No,
email at 6:30.
yeah, so it'll be at 6:30 because both he and I are like, it's kind of work on the different thing on a full time. So 6:30 is the good time for everybody. And then we typically go for whatever time it takes it. Typically like it's anywhere between an hour or two. Like we try to wrap it up no later than 8:30 on Thursday because we understand everybody has different need on that.
So the teaser you gave was way smaller than this, right?
Yeah.
We need to figure it out through these.
Yes.
So that one was, this one is a proposal, another one was more of a problem statement.
All
So
right.
it's not include everything.
This is even more generic and more
Yes.
bigger picture.
This is a bigger picture, but also this one is telling you what is the current state, what they're looking for it and where they want to go in, right? I was able to condense everything into one paragraph
That one,
each,
yeah.
right? And sometimes most of the proposal is not going to be that small that what I kind of showed you. It's going to be bigger.
So all these parts are just part of one problem?
Yes.
Okay.
And that would be a typical case that you're going to see
Okay.
is like that size. Okay. Fine. Any questions?
You're gonna be मांगने वाला है. I said one more.
So our homework is the PHN nursing registration. Is that our homework?
Yes.
Okay, okay, gotcha. That's the 11 pages, right?
Yeah, that's the 11 pages.
Okay, okay. So you want us to answer the questions before Thursday, and if we don't know it, that's okay, right?
Yeah, we'll just have a conversation during Thursday. So just read through that,
Okay.
try to come up with the answer for slide 33 and 35 in terms of what that is.
Mm-hmm.
Okay.
Sounds good. You are helpful. Thank you.
Sure. We're gonna quickly talk about it. So you want to talk about it?
Yeah, so let's talk about that. Since you have a conflict, so see if we can rearrange a little bit.
So it's on, I mean, for me, it's like I'm working with US Bank. I do have few shifts on Saturdays, which is like 9 to 12. And that's so ugly for me that it's really hard sometimes, to ask for a kind of Saturday leaves. So there are 2 Saturdays which are actually not filling.
Which 2 Saturdays you have?
Let me check my calendar real quick.
Check your calendar. One option that Dilip and I discussed is we can have it set Sunday only on that weekend,
Okay.
and then we can extend the camp to
Okay.
maybe another week or 2.
Awesome. Yeah.
Kinda like
Thank
that.
you guys for giving me.
And that's the reason I sent you guys 5 weeks I think camp, right?
Yeah,
It's over 5 weeks.
Sure.
Yeah. So typically it's a 7-session camp,
Okay.
right?
We
So
can extend.
we usually wrap it up in 3.5 weeks. But if you have a question, so that's something that we can talk together as a class.
Yeah.
Because it has to work for everybody.
Next Saturday is not an issue for sure.
Okay, then we can keep it.
I'll be here on next Saturday. for
So
sure.
are we keeping next Saturday, Sunday both then?
Yes, 100%.
So let's put the date, right? So 31st.
But do you guys have any issue? I mean, I want to make sure everybody
Yeah.
has an issue.
How about you?
Nobody's traveling.
Are you okay with extending?
You guys are okay with extending if we have.
So
Going to
is
9
it going
weeks.
to,
It will be 9
Because
weeks.
again, I'm not available on Thanksgiving.
The Thanksgiving we don't have classes,
Classes,
not
okay.
typically.
Typically,
So-
okay.
So we have one reserve week. That was the last 22nd week. That is a reserve week.